Hello. Hello. Yes. Okay. Wait. Hello. Wait. Okay. 1 o'clock now. Firstly, thank you for you all to come to this workshop. And first, I wish show myself the welcome to you. And you know that Yeti DNS project founded this year. We spent several months. Even the coordinators cannot have such opportunity to face-to-face to work and share some information. So today is a good chance to share information, and both from coordinators and some Yeti participants. And we're glad that some people like you are interested on that come to participate, and maybe you can propose some suggestions and comments on the activity we're doing. First, we will go through the agenda. Today we have the initial plan is from 1 to 5, and I was told that we could extend a little bit. It's free after 5, so it's not strictly controlled by the time. We have a compact agenda, about 7 speeches, and leaves enough open discussion at the time. And firstly, we'll show a record from the as part of welcome address.
Hello, I'm Yudo, the President and CEO of BI Group. I'm sorry that I cannot come to here in person. On behalf of one of the organizers, I hope to welcome all of you here to attend the Yeti project workshops. I think Yeti project is a great start for the next generation internet evaluation. This year, we have co-founded the Yeti DNS project along with the Mr. Progresses and the Web projects. Our target is to build a worldwide live testbed to promote future development and new technical potential of the road server systems. The project has gathered 13 research institutes to contribution the 14 IPv6-only road servers to the systems. Meanwhile, I am glad to see some college and institutes also attend this project. So I would like to thank all of you for your hard job in contribution to the internet. I wish the company the success for these workshops. Please enjoy the time.
Sorry. Ludon is the president of BI and my boss, and he's sorry not coming in person. And he asked me to play this record to say welcome and greetings to us all. And at this workshop, I would like to thank to the Yeti coordinators to partner with Ketu and Povich, Mr. Povich, and also Ketu, do you want to say something to that?
Excuse me, just one thing. This meeting is public. It's,
Public, yeah.
It's broadcasted outside and.
Yeah, I use a GoToMeeting and
Okay.
send the link to the.
So nothing
registry.
secret here.
Okay.
Okay.
So
That was.
No secrets.
Okay.
No secret.
Just wanted to check.
Yeah. So we should use the microphone. So
Use microphone
yeah,
and
yeah.
this can connect to the voice to the
Okay.
system.
Okay. So anyway, apart from the Yeti project, I like to welcome you to Japan. And our NOC team has been working several days from the 7 a.m. to 3 a.m. or something like that, and making the network much more stable than we expected. So if you have any questions or comments or something like that, please let us know.
What SSID should I be using?
Regular SSID, IETF,
Legacy network.
Yes,
IETF legacy without
use a
password.
password, but if you want to use IETF, then you have to use more secret IETF.
What is the secret? IETF.
ID is IETF and password is also IETF. Then you have to use WPA Enterprise and take it for AES and something like that. That was not announced yet, but the same with IETF 93 in practice. So if you have an account for the IETF 93, you can use the same method to connect IETF with authentication. But then you have a secret.
Thank you very much for your answer, for explanation. Yeah, I'm not in charge of the wireless stuff, so I don't know the detail about the configuration. But anyway, welcome you to Yokohama, and I hope that we have a good discussion for the day. Thank you.
Paul, you want to say
wanna-
something?
Do you want to just quickly go over some other things, like mention that we're going to have a coffee break? and-
Oh, yeah. Oh, okay. Let's
Bathrooms
introduce
are right there.
Shall briefly introduce this agenda because Paul will first one so you can welcome in your time. And it divided two parts, obviously. First part, Paul will give a background and introduction of his study and work on the route for 10 years, 11 years, yes. And we invite Case to give us an update about AS112 operation. And I will introduce the current status of the Yeti project with some status. And Shan Kerr will give a short brief feedback from the during IK meeting, especially the ASEC meeting is involved. And we have a 20-minute coffee break, and there are beverage later at 3 o'clock, I think. And the second part involves some activities and experiments by our participants. First, Sharon Kerr will introduce the activities done in their lab. Steve Bozeman will introduce some ideas about how to monitor the Yeti real-name servers. And the last two, Dimitri, will give us some activities done by his team. And there leave some free time open for open discussion. And I think that we can extend to before 6 o'clock, I think. It's not a very budget, very tight time. Okay. Any question to the agenda or any suggestions? If there are no, okay, Paul? It's your time.
I know.
And there is a free mic. If anyone wants to ask questions, you can use this mic to net the people with the remote access.
Thank you. Do you have my slides?
Don't you want to say something too?
to us? Oh, okay. I will change to.
So again, I welcome you. Thank you for coming. I realize you might not have come to Yokohama just for this. You had to come in a day early, and we appreciate that. Yeti has some precedents. Most things on the internet were done in an exploratory way first, and then the parts that worked got turned into standards or practices that other people could follow. And I liked that. That was cool. And so when we were trying to decide exactly how to approach the problem of root name server research, this idea came to us when we realized that it was in the finest tradition of the internet to just go do something that would not harm anybody or get in anybody's way or spam them or anything, but that nevertheless could produce good results if there were, in fact, good results to be had. So, now let's talk about me. I have raised a lot of rabble in my time. I am attracted to trouble like a moth to a flame. And so I have frequently been at the center of controversy regarding DNS or regarding the root name server system. Many of you were there, either with me in the center or at the outside shouting at me. And that's okay. I've gotten used to it, and you've gotten used to it, and I'm still here. So let me tell you, from my point of view, the track of time that led to this project. Next slide. So in this room, I don't need to go through the details, technically speaking, of what a root is, except that a root has an identity mapping between
Meta question. Are the slides available online?
all the slides will be made available online. So there's an identity mapping between a serial number and zone content. That's why if you are, let's say, a zone transfer slave and you get notified that the serial number is a serial number that you already have, then you don't have to do anything. In other words, if you can assume that if the serial number has not changed, then the zone it refers to has not, or that it's part of has also not changed. Now, part of what is in the zone is actual data that affects the rest of the system, provides content to the rest of DNS. For example, in the root zone, there is a COM node, which contains a bunch of NS records that tells you where VeriSign is. And without that, COM couldn't exist. And in that sense, that's content that is delivered by the root zone. Separately, though, there's also some metadata. And I don't mean DNSSEC in this case, but rather the Apex NS records. And those records tell you where the root is, which seems a little bit duplicative, since if you're asking the question, then presumably you already know where the root is. But nevertheless, there is an identity mapping of the zone, which contains metadata about the zone, like where the zone is served from. And what that has led to is this belief that there is an identity mapping between the namespace that is created by a zone and the zone itself. And we are ultimately here to challenge that and to come to a finer grained way of understanding zone content and zone identity. Yeah, so you guys know the rest of this stuff, except to say that in the past we have renamed servers. FROOT used to be called ns.isc.org, for example. Then we've renumbered servers. Quite a few of them, nearly half of them, have got numbers that are different now than they were in 1996 when those names were first assigned. And that works. We've proven that it works. We're all here. We were all able to buy our airplane tickets. Therefore, you can change root name server names and root name server numbers without breaking the internet. It has to be done carefully, but it can be done. Go on. So M was first. Kato-san told me that he had 2 mroot servers in the same data center because there were 2 internet exchange points in the same computer room, and he wanted to have mroot be directly reachable on both of them. and he realized that there was absolutely no reason why he would use a single mRoot server to serve both Internet Exchange populations. And I thought this was really quite interesting because it meant that the identity of a server was not one-to-one mapped to an IP address. In this case, we had two servers answering the same IP address with the same content, and we all treated this as safe and normal. Everything having to do with the root name server system is touchy. And so when you make a change in the definitions like that, to where an address no longer pertains to a single server, a lot of people get up out of their chairs and wonder, are we changing who's in charge of the internet, or are we changing how the internet is operated or managed or whatever? And the answer, of course, was no. So we did something very similar. I actually did it by mistake. I had two froot servers in Palo Alto. I was the froot operator at that time. And we were connected to PAX, and I had two servers in case one went down. And the idea was that I would bring one up, and when I was ready to take that one down for maintenance, I would bring the other one up and then take the first one down. And one day, I brought up the second one without realizing that it was coming up, and it worked just perfectly. In fact, it load shared because of something called ECMP, Equal Cost Multipath, which is built into OSPF. It's not an option. It's not something only Cisco does. If you speak OSPF, then you do ECMP. And what that meant was that we got load balancing between two servers that were both connected to the same upstream router. And again, this was a mistake. I did not know that I was experimenting, but it went well. Even now, we don't worry that much about experiments of that kind, because if a root name server does go down, not that they do, but if it does, there are plenty of others. And there have been some widely publicized DDoS attacks in which one or more root name servers were widely unavailable, but it doesn't matter. As long as any of them are still available, the system still works. So if you trip over a power cord, you're not going to get a phone call about it. Just plug it back in and everything's fine. But anyway, the important thing about ECMP is that it doesn't look just at the IP address. It looks at both the source and destination IP address and the source and destination port number. And that keeps all of the TCP segments that are part of the same flow going toward the same endpoint. And so these froot servers, since they were running at that time GateD, since changed to Zebra, they looked like routers, and they were in fact routers to this address that was hanging out on one of the loopback addresses. And so this whole new methodology was born. And now I think this is pretty popular for not just root servers, but all kinds of servers all over the place are using equal cost multipath and host-based routing in order to do their load balancing. We used to have a separate powered box just to do the load balancing, which is an additional power cord to trip over that we don't have anymore. So I kind of like this. On the strength of that, we added an froot in Madrid. This was at Espinix, which is an internet exchange in Spain. And it's a slightly different variation of the same concept, where we're advertising a well-known prefix, which contains froot, and we're advertising it in BGP. And so we had to make sure that every address in that prefix would be answered the same way by whatever servers were in Madrid as had previously been answering in Palo Alto. So we had a problem with the NTP server, clock.isc.org, was in the same prefix and had to be renumbered. That IP address is still hard-coded into a lot of places, and my friends at ISC tell me they still get an awful lot of NTP query traffic to the froot prefix. Every other root name server that is renumbered has done so to get out of a large /16 block and into a small, more anycastable /24 block. And every one of them reports that the IP address of their original address is still receiving quite a few queries. And this informs us, not with any rigor or any science behind it, but this informs us that yes, you can change the address of a root name server, and no, that will not break the internet, but it doesn't mean that it takes instant effect. could be that there's a long tail of 20 to 30 years before the old address will stop getting queries. And some of the hard-coded IP addresses there are in ROM. They're not in text files that you can edit. They're built into embedded devices that will have a very long life.
Wow.
And malware. So this caused huge controversy. In fact, Vint called me. He was at that time the chairman of the ICANN board. And he said, Paul, I saw the news. You have added an FRoot server in Madrid. I said, yes. He said, I'm curious, who gave you authorization to do this? And I said, well, Ben, John is dead, and so I'm a little short on authorization at the moment. It just seemed like the right thing to do, so I did it. And he said, thank you very much. And I guess he had to answer questions from Congress or something about that. But it was huge controversy because this is changing which countries are root name server operators in a very real way. And those decisions used to get made in smoke-filled rooms full of people who know the secret handshake, and I was not one of those people, so what the hell was I doing changing the shape of internet governance like this? So on the strength of that controversy, I found friends in Beijing, because at that time China was also very misunderstood in the internet governance world, and we put an FRoot there because I wanted to make sure that if people were going to get upset about this, they would get really upset soon. So on the strength of FRoot's success, I think all of the root operators decided that this was a really good thing to do. It doesn't really help with performance or load, but it sure helps you resist DDoS, because DDoS tends to be local. And so if you have a DDoS that is hurting you in Korea, you might want to still be able to serve everybody in California, or vice versa. And so that's, to me, really all it does. It's a high availability play more so than a load balancing play. But it will reduce your round trip time, but not in the way that you'd like it to, because fairly often the shortest path in BGP terms is not the shortest path in terms of round trip time. And so you can often increase your round trip time. You'll be in the same city, you know there's a root name server here, but you're not talking to it because the local providers don't peer with each other or something like that.
Yeah.
But in any case, it was the same zone, same servers, same addresses, same operators. We didn't make any changes to that. And that, to me, was the real definitional perimeter of internet governance. Is, what is the zone? It's the root. Who are the servers, A through M? What are the addresses? They are the addresses that are well known. Who's operating them? Same bunch of folks, right? I didn't give the root password to anybody in Spain or anybody in Beijing. And so I thought, we've figured out that the identity of the zone does not include the geographic location of the servers, any more than it would include the operating system version or the name server software version of the servers. Next slide. In 2005, I noticed that we were trying very hard to convince ICANN that it would be safe. We, sort of the root ops and the DNS mafia, most of you in this room, we're trying to convince ICANN that internationalized domain names were not really a change to the protocol. They were just, interesting hexadecimal gibberish as your query names, and that they should really just allow international top-level domains, and that they didn't need to coordinate with anybody about it. It was just content. They were not buying it. They were not listening. They wanted a study. They wanted a proof. They wanted somebody somewhere to write a report that said it was safe, so that if it turned out that it wasn't safe, they could blame those people instead of having ICANN be blamed. And so I proposed what I then called alternate rootism, sort of a play on words. Most alternate roots through history have offered different namespaces. For example, .xxx used to mean something special if you were at the Schiphol airport, because there was a provider who had a contract with the folks at the Schiphol airport to put an override for .xxx. And so if you were there, you could serve certain porn sites that didn't work anywhere else in the world. And they thought, on the strength of that, they might be able to be first in line when .xx was eventually allocated, but they weren't. They thought that they could get other parts, maybe not airports, but also coffee shops and ISPs to also join in this and allow .xx to be created by the community without any top-level authority from ICANN, and that also failed. But that's what alternate root means to most people, is that you're trying to pirate the namespace. I'm not trying to pirate the namespace. I don't want to be anywhere near the decision-making process about what the namespace has in it, but I'm very concerned about how we serve that namespace. So I proposed, look, we can add IDNs because IANA is capable, IANA being an organ of ICANN in this case, IANA is capable of creating another root zone that has different servers. And we'll just get some or all of the existing root servers to offer an alternate address, and then we'll publish a second root zone that'll have different NS records at the top. And that is where we will add the new, what I call advanced services content. It wasn't just going to be IDN, it was also going to be the V6 addresses. Everybody was terrified that Quad A records were going to break the internet. And so I made this proposal. There is slideware online that proves that I was that crazy at that time, and there was huge controversy. Because what people said is, if you're changing the zone in that way, ICANN has to get permission from the Department of Commerce, and VeriSign has to sign off on it, and everybody everywhere has to be sure that they won't get blamed for it, and we can't do that. We are not the community who could do that. So this idea languished. And there was this assertion that the zone was not just semantically equivalent to, but had an identity mapping with the namespace. And that if you tried to create more than one zone that represented the same namespace, that was dangerous. In the same way that putting a name server in Madrid was dangerous. In the same way that putting a second froot server in Palo Alto or a second mroot server in Tokyo was considered dangerous. It's dangerous until you do it and nothing bad happens, and then it's not dangerous. That's been my experience. Next slide. So sometime in the 2013 timeframe, ICANN commissioned a number of panels. There was one on internet, I don't know, it was internet naming basically, but it was not just naming, it was chaired by Paul Makropetros, the inventor of the DNS. And he was looking at, what could we use either instead of DNS as maybe the future of naming? Is there an evolutionary path that the internet could use to have better naming than it has now? And it was a fairly broad inquiry. And the panelists came up with all kinds of ideas. My idea was to take the experience we had gained from AS112 with unowned hierarchical anycast and apply it to the root. In other words, let's have ICANN create a second root zone that represents the same namespace, but has different name servers at the top. And let it be that those name servers have addresses that are not specific to a particular operator, but rather are open to the community, that anyone on the internet can turn on a server for this. Now this sounds like a disaster waiting to happen, because it means that any ISP or any airport anywhere who wants to insert content into the namespace could then do that, because you've got your laptop or your smartphone or whatever that is, whatever the recursive name server is you're using has got a hint file that says that the root name servers are these just random addresses out there, that anybody can advertise, anybody can serve at those addresses. DNSSEC is the reason that can't happen. Now, it's been widely noted that DNSSEC is not really deployed yet, but the fact that DNSSEC is partially deployed, in my opinion, means that any such piracy will be so unreliable that it will not profit anyone to do it. Nevertheless, there was huge controversy, again, which was that, well, you can see it here on the slide. I'm not going to read it. Well, I should for the audience on the phone. That there would be a lot of unknown operators. We wouldn't know who they were. To me, it seems like a feature, but that's a source of controversy. And most of this root name service would go unmeasured. And let me just say, we're starting to measure it now, but historically speaking, the root name server operators have not really been forthcoming with their statistics. We have Lehman in the room, who has chaired the RSAC and has led a true revolution in transparency there. So recently we've started to measure the root name servers, but historically we haven't. So the fact that a lot of the queries that got answered would get answered by people who were not participating in statistics gathering was treated as a problem, but it was never a problem before, at least not a panic level problem. And finally, if there was a problem, if you then didn't get an answer, you got the wrong answer because some server was misconfigured, you wouldn't know who to call. Well, frankly, you don't know who to call now. You call your ISP, they might be able to figure out who to call. Most likely they're going to post something on a mailing list somewhere, on the NANOG mailing list, for example. You know, there is some truth to this. If you can't get the identity of the server operator who's giving you a bad answer, then you really don't necessarily have any recourse. So that's why my proposal took that into account by saying there should be 2 different servers, each having v4 and v6 addresses, and no one should operate a server on more than one address. And in that case, a bad server would cause you to try the other server, and hopefully it was operated by somebody who was not having a bad hair day on the same day. But again, huge controversy. A lot of people believe that the zone and the namespace are identical, that they are the same thing, not that they are semantically equivalent and that one implements the other, but that they are the same thing. And especially now, in light of the IANA transition, no one wants to do anything controversial because they don't want to provoke the question, does this mean you're no longer responsible for the namespace, or does this mean there's multiple namespaces? What exactly does this mean? I'm a congressman, please explain it to me. Seems like a bad course, so I understand why we're having trouble now. Next slide. So, realizing that not all controversy can be sidestepped or ignored, I eventually realized that I should try to work together with other people who had similar interests, and that's how Kato and Davey and I got to talking about this. And we should also come up with something that we could do that might seem controversial, but that ultimately it was so obviously benign and obviously harmless that we would be able to proceed with the work instead of spending a lot of time on messaging. And that was the sense of the Yeti project. So we had to make our own DNS set keys. Obviously, IANA is in no mood to loan us their signing keys so that we can create an alternate zone representing the same namespace, and they don't feel like they are authorized to create that zone for us according to some other set of rules, because again, they would need the Department of Commerce and all kinds of other people to give them permission. So we had to make our own keys. We are now, as of yesterday, operating 3 distribution masters, which are peers. You'll hear more about that when Shane talks later. So there is not a single entity like IANA or ICANN who is capable of taking this namespace sideways and using it for commercial purposes or political purposes or anything else. The 3 distribution masters all have to agree before changes are made, like adding more server operators. We have 14 servers, 13 operators. So this slide is wrong in that regard. I've volunteered so far, and they are pulling the zone, and they are sharing statistics. And the statistics are being gathered by the BII team, and there's a website where you can view them. We have a couple of dozen recursive operators who have changed their hint file and their root key to be this system instead of the IANA system. They've done this on the strength of our assertion that we will never add or delete any top-level content, nor will we change any of the metadata, like name servers, for any of the top-level content. In other words, we are entirely faithful to the IANA namespace. This is in no sense, no way, no possibility can it become a namespace piracy project. And we need more recursive operators. Certainly all of us at home, Davey, Kanto, and I, should be using this, and probably are not because we are lazy, not because we don't trust it. But but we are looking for a lot more query load because we'd like to start doing some science. You know, ultimately, we didn't build this just to prove that this could be built, but rather as a foundation for other things that we have always wanted to know. For example, how many root name servers is too many? If you had more than 30 of them, what would break? We'd like to know that. And we know that IANA is not in a position to experiment with that because they have a job to do for an audience of 2 billion internet users, eventually to become 6. We'd like to find out if GHOST will work and other crypto things. There's this elliptic key DSA thing coming out now that we'd like to see if that'll work. We'd like to test this RFC 5011 KSK role. There is an idea for, you know, signing the new key or the old key set with the new or I don't know. There's a way to change the KSK, but right now IANA is in the process of writing really long reports about how dangerous it will be and how many steps that process will have to have. We, on the other hand, if we can just get everybody to agree to try it, can simply schedule an experiment and start to find out. We will not learn as much as IANA will learn because we have a lot of selection bias in our operators. In other words, our operators are all likely to know this is happening. That's not going to be true for IANA. So it won't be directly applicable result, but at least it'll be some kind of result, and I don't know another way to get it, because a lab test with a lot of virtual machines and a lot of fake networks will not create the kind of diversity that it takes to find out, does eDNS actually work? Does TCP fallback actually work? You know, through real middle boxes that are in people's data centers rather than through make-believe middle boxes that are in our virtual test nets. We want to know about rapid ZSK role. What if we change the key every month or every week or something like that? What if we add and delete servers all the time? How long is the tail of queries going to the old address? And we're going to try at some point, I assume, hierarchical anycast. That is the thing I wanted to prove could be done as part of the ITI panel. I still want to know whether it could be done. And that may mean that we have to create more than one Yeti root zone with different NS records at the top of each one. Probably all signed with the same key to keep that confusion down. But that's a type of experiment that we can do once we have this test bed and it's global and it's transparent and it is community driven somewhat. IANA has been asked how many queries per second can they tolerate, and also how many zones can they have. Now, how many top-level domains can they have? And the root ops didn't really know how to answer this. It's like, well, we think we could tolerate a lot. We think, and IANA said, well, at what point would it begin to fail? Well, okay, in order to know that, we would have to make it fail. And we're a little bit reluctant to do that. Since we is the root ops. Whereas under these conditions, you know, as long as it doesn't all fail at once, then nobody who has switched their recursive over to this hints file is going to have a problem. So we can actually do some stress testing. Now, one thing we're not willing to do is to modify the namespace. And so the question of how many top-level domains is too many is one that we are not currently, I cannot currently imagine how this project will answer it, because that would require that we create our own namespace, and we're not going to do that. It may be that in the second year of this project, we've currently scheduled it to go for 3 years, it may be by the second year that there's no other controversy and we can actually ask the community, could we create a lot of random TLDs just for the purpose of finding out what their impact will be on the zone transfer process if we point them all at, you know, localhost, or point them all at some test server somewhere. So we may be able to stretch the limit of that, but at the moment, I don't imagine that happening. So yeah, there's a whole bunch of things that we would like to discover. The existing system and every test bed that I have helped build or that I'm aware of other people building are not in a position. So that's why we're here. And that is the path I walked to get here. Next slide.
Mm-hmm. Yeah.
That's all I got.
Regarding the AS112 style of distribution, I remember that the people at the YPNCC made a survey of the response of requests sent to the K root. And when they asked the NSID of the name server, some of the NSID were never allocated by the YPNCC. So there are apparently many WOG K root instances. Apparently, they all serve the same root zone, so it's not a big problem. But still, we already have hierarchical anycast, even if it's not volunteer. And one of the consequences of anycast is that it's much more difficult to detect that there is someone else announcing the prefix. So in a way, it's already people are already experimenting with this sort of thing, without, of course, any approbation from the root up.
I remember when I first heard that CERNET, Chinese Education Research Network, CERNET 2, had servers listening on all of the root server addresses, so that we would never hear any of their queries. And I remember reaching out and asking, why is that? Are you concerned about surveillance, spying, what it is? No, it's just a simple performance question. And I said, but it's my address. Why are you answering things that are destined for me? And they said, it's our network. We'll do whatever we want. And so there it sits. Now, in my model for hierarchical anycast, these well-known addresses would be potentially inside of our laptops. It may even be that we would run a root name server on our smartphones. Because hierarchical starts with the first network, and the loopback is your first network. That's the network that is closest to your application. So I know this is happening. You're right. Thank you for pointing that out. But it has not been institutionalized, which means that no one in power is currently capable of getting blamed for it. We want to change that. If there are no other questions, I'll pass it back to Davey. Thank you all again for coming. This is great.
Thank you, Paul. I quite agree with saying a quote from Paul is that the project is totally driven by the community. That's our purpose to, as a BI, as a coordinator, to build such a platform to conveying the people with the same interest. Okay, thank you again for Paul's talk. So next speaker is good case from the org community, from the org, DNS org. Okay, the topic is 112 operation update. Thank you.
Okay, thank you, David, for the chance to speak here. I hope to learn a bit more about the Yeti project. Although I'm giving the talk, most of the work that's been done on this and most of the slides are actually my colleague William's. William has been involved with the S112 right from the start. It just happens that he eventually came to work for OARC, where we provide some of the resources to coordinate the S112 project. Next slide.
I'm sorry, I would need to, there may be some box jump out to block the hotkeys. Okay, right now.
So hopefully most of you are familiar with OARC. What are we here to do? We're here to basically get a better understanding and protect and improve the security and stability of the Internet's DNS infrastructure. There's a bunch of ways that we do that. We do some research. Mostly we're in the business of facilitating other people's research. We have various services and tools in support of that. Community building, having all the right people in who are members of our organization is very important. Finding an environment where they can share knowledge freely, and also just trying to increase awareness. So, sorry, next slide, please. How would you maybe explain the work in terms of layman's terms? One way of thinking of it is it's a library. Our books are our DNS data. We try and archive that data in perpetuity. We try and make it as accessible as possible. We do some work in indexing. We have members who we provide various additional facilities to. We have events, which are basically our twice-a-year workshops. These are some of our members: registries, registrars, vendors of DNS software, most of the major ones, internet providers, and about just over half of the root operators as well. Okay. That's what we do. Our next workshop is immediately before the Buenos Aires IETF meeting, so I look forward to seeing many of you there. And on to AS112. So what is it? It is completely decentralized. OARC doesn't actually run AS112 infrastructure. We just facilitate other people who do it. And basically, it's junk sink. We are the internet's black hole, the scrapyard, the dustbin, where all the bad queries from IANAT or from what should be internal only RFC 1918 address space get leaked out. And the idea is that we're absorbing that, and the AS112 and any cast infrastructure is absorbing that as close to the source as possible. AS112 is autonomous system number. Unlike most other ASs on the internet, it is operated by lots of different organizations with local instances, and it's a fixed set of network prefixes. Well, it's interesting. It's anycasted for better performance, but actually, whether you anycast the root or AS112 for performance or DDoS or latency or junk syncing, I think is a very interesting question. So, there have been some developments in the AS112 space recently, 2 new informational RFCs. 7534 is an update of the previous AS112 informational RFC 6304. It adds a number of things, carrying your AS112 queries over IPv6, and also making sure that AS112 resources have special status in the ANA registry. And also some information on logging and some considerations of leaking information if you're behind an internal NAT. 7535 is new stuff, and basically what that's doing is that uses DNS to add a mechanism so that instead of the list of AS112 prefixes being hard-coded, there's a way of dynamically updating that without every single AS112 infrastructure having to do hand configuration in every one of the nodes. Anyway, there's more information about the project on the URL. It was on the screen a second ago.
Sorry. No, nice picture.
Some AS112 instances use OpenPGPT, some use Zebra. Okay, next slide, please. Okay, so as a result of these changes, the RFCs went through the RFC editor process, and Anna said, yes, let's do this. Unfortunately, it was done without a huge amount of notice, which is it would have been a great data gathering event for OARC. But basically, if you're running AS112, you should expect high IPv6 traffic now, follow directions in the URFC. And as well as the mechanism for making it easier to add prefixes being activated, there are actually some new prefixes that have been activated. The consequence of this is that there are now IPv4 NATs which are using IPv6 DNS to ask about IPv4 reverse jump, but that's just the universe that we live in these days. Okay, next slide, please. And here's some data that William gathered he also operates his own AS112 instance at the Ottawa Internet Exchange, wearing a separate hat for his OARC one. I think that's where this data came from. And that's just basically showing you the proportion of AS112 queries that are coming in over IPv6 since the change. Okay, next slide. One of the things that William's been doing is running some surveys every year. One of the coordination activities that we do at OARC is to maintain a list, a volunteer-maintained list of who runs AS112 instances. But as Paul said earlier, it's like once you start doing hierarchical anycast, you can't actually tell who's running it. So there's the list, and then there's all the other ones. How do you find out the ones that are not on the list? And there are some useful tools out there, we have a huge problem on the internet with open DNS resolvers, but actually, if you do it ethically, they're a very valuable resource for reflecting traffic through as a way of doing research. So that was the main methodology. There are other ways that you can do it by using the route views service, for example. Anyway, he did the survey, the results are published to the website. You can find out all kinds of interesting things, like what kind of scrap of land in the Pacific is running AS112. Next slide. But the methodology is fairly straightforward. Obviously automated. There are various open resolvers lists out there on the internet. Find ways to parallelize that, but also at the same time not swamp the open resolvers with too much traffic. Bring the data back together, do appropriate analysis, deduplicate, and then publish the result. So what were the results? Well, there's about 7.6 million open resolvers in the internet. He got response from just under 1 million for the questions that he was asking. A number of observations. S112 nodes need to identify themselves better in terms of operational data and not just sort of random strings about where they might be. He's only doing this once a year. There's a question of, we in theory do Anycast to get the nodes, the clients close to the nodes. In practice, it doesn't work as well as that. Peering does not always happen the way that it should for reasons of intent or less, due to accident or intent. And there's a proportion of AS112 traffic that goes halfway across the road just to sink the junk. Doesn't seem to be too much churn. The number seems to be reasonably stable. The most popular node is operated by Highvein, an ISP in France. And of course, what do we mean by a node? Well, again, it can be, it may be a single physical server, or maybe a cluster, or maybe something else. Next slide. Basically, he's plotted out where the operators are and where the survey found the nodes, and I'll show you a couple of maps in a second. There's a lot of AS112 servers in Europe, but they don't always get used by European clients. And also, there's some organizations that operate higher density of AS112, for example, VeriSign. So the first map, so this basically shows all the AS112 nodes that we know about because the operators told us about them. And then if you look at the second map, then you'll see there's a pretty close correspondence, but it's by no means completely congruent. So next slide. Devil's in the details. 2015 did the same, so I think that reflects the fact that the Williams failed to spend a bit more time on the coordination. But it's still useful to do this. But of course, what's even more useful is what is the mapping between the nodes that are the clients that are using these AS112 servers and the actual nodes that are using it. But we need more data from the operators, and we haven't quite got there. But what William did do is that he drilled down, next slide, on national research and education networks. So, obviously he's got adjacency to Canary in Canada. This is networks like AAR in Australia, GAIN in Europe, WIDE in Japan. And although they have commodity internet access, they tend to be semi-disjoint from the global routing. There's sort of more policy constraints there. It's around 16,000 routes. And it's actually, well-established principle data point that there's actually not a lot of router TLD servers that are actually on the academic networks. Finding them could be an interesting project. So where are the AS112 nodes on that? Generally, AS112 nodes don't have default routes. What is the mapping between the clients on the academic networks and the AS112 nodes on the academic networks? And to what extent do they leak? Where does the leak go? It certainly seems like it must be an interesting project to measure. But if you're going to use the open resolver methodology, then you have to make the assumption that the distribution of open resolvers on the academic networks is roughly the same as the distribution of resolvers on the regular internet. So next slide. So basically, about maybe a fifth of the open resolvers were indeed on the academic network. Needless to say, lots of academic campuses have got lots of open resolvers on them. That can be quite scary. That's quite scary actually when you consider that there's some really cutting edge bandwidth available on these networks. They could be potentially dangerous abuse engines. But again, it doesn't really tell us a lot about which AS112 node is seeing which client. But if you look at the next slide, you can see there's a visualization in a second. Sorry, if you go back to the previous slide. You can see that we'd probably get a different picture if we use a different methodology. For example, if we use data left internet capture, which is another thing that ORC does with the root operators. But you know, research networks can be quite leaky. There's quite a lot of routing asymmetry there. See, you know, bilateral academic arrangements for specific projects or special projects. You know, how much AS112 traffic is not symmetrical is probably an interesting question in its own right, but it's a separate question. But using the open resolver data on the academic networks only, the next slide shows essentially what we determined where the clients were. And then next slide. So conclusions about this. Generally, the institutions prefer the faster academic networks over the commodity internet, but this actually leads to greater distortions in terms of congruence between where the clients are and where the servers are. It would be nice if the academic networks appeared more at the major European internet exchanges. There sure would be an advantage in having an AS112 node and an Australian academic network. Probably with some advantages to be done in Southern Central America as well. But of course, it's not just about AS112. If this is saying that we need more AS112 nodes, maybe we need more root and TFD nodes in these places as well. Being able to do it just IPv6 would be helpful. But of course, you know, we can easily overthink the fact that actually what we're trying to do here is solve a problem, and if people didn't create the problem in the first place, then we wouldn't need to think about it so hard. Anyway, next slide. Another thing that William did as a kind of education exercise was some visualization of the AS112 draft data that he gathered. And basically, the bigger the blob on the visualization, then the more junk traffic is coming from that particular place. So you can essentially, you could use something like this as a tool to educate the enterprise networks or the academic networks, the institutions that are leaking the most. So let me show you the visualization on the next slide.
What does this mean?
So yeah.
Visualization?
And that's basically it. I think the one sort of thing I wanted to finish up with is basically the idea that we don't anycast root nodes in order to necessarily reduce latency. It's more about making them DDoS proof, load balancing the traffic. And AS112 is a little bit like that as well, but actually the main reason that you're doing AS112 is to sync the junk. But if you actually look at the traffic that goes to the routes, then the traffic that goes to the routes is 90% junk. So when you're thinking about schemes that are there to potentially figure out how we can better locate the root servers, maybe what we actually need to think about is, well, where do we put the root servers to optimize syncing junk? And then once we and that actually maybe is a bigger consideration as any of the other considerations for looking at root servers. So that's about it. There's a couple more slides in there which are just kind of background if you want to read around doing that. So that's pretty much what I had to say. Be happy to take any questions.
I have one.
Mm-hmm.
Okay, thank you. So the AS112 sync the jump query, right? But the query to for upper address, private address, right, namespace, they first go to the root server, then to the AS112 server. Is that correct?
So you're basically saying somebody is not going to sync jump to the AS112 server until
it's directed
first.
It will reach the root server at the first.
Yeah,
then,
I mean, yes, but you know, the thing to bear in mind is that there are caches there. So once you start caching your AS112 server, then hopefully that's still offloading a lot of the jump from the root.
Okay. Do you have one? Yeah.
One question related to the Yeti project. As far as I know, now that we have the new RFC, which allows to use the DNS to send traffic to the new AS112, was it used for TLD yet, such as .local or .home, which makes a lot of junk requests to the root? As far as I know, there is still no use of this feature in the root. Am I correct?
Not as far as I'm aware, no. You need to ask a root operator. I'm not a root operator, but
okay. Because we could test this on the Yeti, but in one way it could be seen as adding things in the namespace. So, in my opinion, if the name is in the special domain registry, like local is, for instance, it's not a problem, but this is something we could discuss in Yeti.
So it's .onion delegated.
Yes, .onion and .local. But the biggest one in terms of traffic in the root is .local by far. So if we add just .local, we solve the majority of the junk.
Because of politics, I would not be willing to make that change to add a .local delegation toward AS112, for example, unless there was clear consensus from the IAB and ICANN and so forth. It's a good idea, yes. This particular foundation would not tolerate that stress well.
Even if the name, because the fact that the name is in the special domain name registry means that in a way I am now already accepted that it will never be delegated in the official root. No, yes. Too touchy.
You stepped right into the whole debate between who is the real manager of the root, which, if at all possible, any sane person will run away screaming from. So I mean, I agree. It would be interesting to see what happens from a technological point of view. But
follow up. So I think this is a good idea. I think that delegating .local to AS112 is something that the IETF should do. There should be an internet draft, there should be an RFC, there should be community consensus, because if it is not going to be delegated, then I would certainly treat its queries the same way I would treat RFC 1918 PTR queries. But that is, again, that's something that I think that the IETF should do, and it is not something that I would like to see Yeti do independently.
Yeah, I think there's an argument for keeping your experimental test beds and your production stuff completely separate and not crossing the streams there. It might be less controversial to get .local to AS112 than it is to Yeti. On the other hand, I suspect if we went to the AS112 operators and said, well, how about delegating .local to you, they would say, we want some data first. At which point running an experiment might be interesting. But anyway.
Is that data not auditable? I'm just wondering if the data requires an already there in the digital data sets. Of course, that makes sense.
Yeah. Okay, I think I'm done. Thank you.
Thank you. Okay, thank you for case. Talking about AS112, and the next slide is mine. Oh, I work by myself.
do you want me to draw this one?
Okay, I make some script here.
Oh.
So, that's right. Okay. This part will introduce till now the current status of the Yeti project. Actually, it's related to the testbed technically, and frankly speaking, that we use months, maybe 3 or 4 months to build this testbed. In the beginning, we are not, fully planned for the project
by some rule, some specification of how to join, how to add a root. And we also spend some time struggling to debug the system and sex for both mail to send many the mails to us. So we build a monitoring and react to every bugs we receive. So it seems that kind of now it's technically engineering work almost done, and we're looking for more comments from community and some idea we can discuss here. Okay, today I want to introduce very briefly about background from my personal view, because Paul Shay as a coordinator already told some motivation behind for many years. And I will spend much of time on the Yeti testbed and statistics related to distribution master, how we coordinate and authority server. Now we have the volunteer participant here, and we also introduce current reservoir and traffic, and also pay to brief introduction, give some links about data connection and monitoring inside a BI lab. And also there's another talk in the second section about how to monitor the Yeti routes. And I will report some technical findings and bugs as we spend times to build this system and debug. So let's come to the conclusion. Okay, as a research project, I usually first to do some survey and to know current state a lot. There are some links and some documents I personally want to recommend. Some audience may be the first to know and to step into this field. The first one is IANA panel and technical reports. It's introduced by Public Shay already. And there are some ICANN documents. I do some advertise for this document. And they're really good documents and help us to know what's the technical aspect, measurements, and some metrics of the system. And there is a work I personally involved is history and technical analysis of naming scheme used for individual root servers, because there is history that the name changed, and there are still options that the future root server can choose. In Yeti, actually, we use a different name scheme. We can call it original name scheme that use independent and separate name. Not actually use the same domain, parent domain. Okay, and there is also some efforts in the ICANN on the KSK role plan, and Shane will give a short introduction of that. And there is a we can call it paper by Jeff talking about scanning the routes. You may notice that there is a competing draft related to the scaling route, and we co-host the BI sponsored the Hanka workshop to discuss how the route can scan, how the route the server can pervasively distribute it. And there's some ITF work about DNS route system that I'm interested in. There are still many related to the system, but I am interested with the three of them. There are two draft, and one is in the last call, and one is here in recently they discussed the priming to the roots. And I also pay attention to both mails the document about privacy, because in the introduction it introduced the concern of privacy issues when the query sent to the root system. It's not particularly the root server's question, but it's a problem statement I will mention later as a Yeti concern. Okay, just brief. And from my personal observation, Shana, I discussed what makes the root system special. different from other authority server. We list some. Maybe you agree, and if you not agree, you can correct me. The first one is the top of infrastructure of the DNS, and regarded as the entrance of the DNS system. And the priming process, I once spent some time testing prime exchange, and HIN5 stuff is not fully documented as part of DNS protocol now. And I also noticed that the parties produce root zone, sign the zone, and distribute the root zone by various parties that depend from the ordinary authority server, the TLD operator. And the key skill of root zone is trust anchor. Definitely, there are no parent DS that make it very special. And also related to the technology of Anycast, the DNS system rely heavily on the networking with BGP routing. That's maybe some TLDs use in the technology, but roots, well, use this to span its instance. Well, currently 500 instances now. And the last one, I think for some non-technical people will treat the roots as a very special for internet governance issue. Some views the root as control of the internet. Well, okay, I just list out there. If you have any want to talk, we can later to discuss. And what is Yeti? I think I don't want to spend much time to introduce Yeti anymore. And I just want to focus that it's not easy to ask the current production system operator to do some research on the production network. So we want volunteer to do something to give some evidence or some information helpful in this field. And okay, firstly, I think we should make clear the problem statement of Yeti, what problem we want to solve, or what hypothesis we may have in the research project. I think firstly, especially regarding how to scan the root, people may think that there's no technical concern. There's not much issue related to such problem. But I want to identify that there is conflict between the DNS synchronization administration where the network autonomy. It results into two problem. Problem maybe for some people, problem maybe not for some people. The external dependency. We found that the local for some network, local services rely on the external root services. If their outlinks are broken, well, even the local service is okay. It will outage. It will cause outage of network and services. And it also requires external management and support from outside. It's a sign of external dependency. The administration of the network autonomy system cannot manage the services just locally. It's not real ideal. So the external dependency also introduced another issue related to privacy. Is that that information leak may caused by the DNS root lookup. Maybe some people will not much care about this this concern, but people who don't want the information leak or some surveillance risk will care much about it. The FCC 7626, the DNS privacy consideration, tells some evidence about privacy happen in the DNS, especially the root system. They may have some workarounds to hide some secondary domain information, but right now it's still the risk still exists. And there are also some problems raised from IPv6 and DNSSEC and some management considerations. And Provixi already told some. And from my perspective, I'm I have background in V6 and V6 transition, and I always confused about if we use dual stack, the IPv6 development actually has a competition with V4 regarding the performance, regarding to the resource located, and references on the left, the end system or the router, middleboard, the routers. So one question is that how system can survive without V4 support, and also V6 introduce different model of fragmentation. So that's may introduce some new issues here, and we also we do have found some bugs and technical findings here regarding to the IPv6 roaming environment. And also case rollover and remembering issue. More information about the problem statement of Yeti can turn to our GitHub project. The most of the documents are in this doc directory. That one of them. Okay, there are some hypotheses and for some scientific exploring and some experiments we expected on Yeti, and there's a list of the experiments we were going to do to verify, to test the hypothesis we have. We assume that the root system can work on V6 only, and I think we can also assume that there is some way to roll the key and our algorithm as well, and rely with higher frequency and with more root server and introduce multiple participants in the root zone management. And people may argue that our activity or Yeti projects into just ask for democracy and transparency in the root operation. Well, it sounds like it's not pure technical problem. Well, it's a political one. I have to say that I want to quote a saying from this ITI technical report that I think a good design, a technical design, could allow political process of deciding the way that people want to achieve one concern. And I also want to say that only when people take it seriously, the people will take it seriously or call it technically only when the issue matters for the people. So like privacy, like external independence, and that's what we care about. So I think there's some technical work can be done in testbed. Okay, let's spend some time introduce background and motivation. And the design for the Yeti, we compare the two models. Current model that ANA, NTIA, and DM work serially to keep the namespace, vetting the root zone change, and assign distribute the root zone file. And each, because there's only one DM and one hit file, so there a group of root servers, certain root servers that we all know now today. And the Yeti mode based on the assumption is that the unique ANA namespace can be hosted by a different multiple group of DM and all different group of root servers. So that's the basic idea. And actually now the Yeti testbed basic configuration, we have 3 DM. We distribute the root zone file independently, and we also leave the room for the DM to coordinate. And it's also the Yeti now working this model, and recently we were verified can work, and actually it's can be treated as another model, alternative model to increase the number of root server instead of increase from 13 to 14 to 15, but by increase different group of the root server in that way. it seems like approach between the current and the universal owned and cast address. It's a bit the middle to guarantee the measurement, guarantee the digit, DNSSEC. So, okay, I will introduce each part from the DM, root server, and resolver. And first one is the DM setup and coordination. Currently, the IANR not notified our server, so we first download and root zone from where the F root. It seems the best root server from China, from BI's lab, to have best performance, no latency. And then we make modification to make change to the IANA to Yeti root. And then we sign the new Yeti root zone. Then we publish the new Yeti roots zone to our root servers, which compose the distribution network. And as I said, that now the current DM was not notified by the IANA, so we need to set a timing to fetch the zoom. Now we at the 3DM fetch the zone every hour and at different timing, as we show in the picture. The logic behind is that the F root updated its zoom data randomly in minutes, so we leave 20 minutes as the interval to catch up the root zone. And we also have an observation that from the end change, the first root server changed its zoom until all the root server, all the leaves change the new serial number. It takes roughly 20 minutes, according to our test, from the root to all the leaves of the current IANA system. So we leave 20 minutes as the interval, time interval. And in order to, yes, now the BI and wide and TIS FDM work independently, but human usually have easily to make errors and also not strictly to some data. So we to guarantee the consistency of the system, we set up 3 repo to centralize some key information like ES key, CS key, and the current the root server list, Yeti root server list, and another file contain the IANA serial number that to be triggered the update action to the system. So that's a kind of centralization between the 3DM. It's kind of centralization is a compromise to the independency of the operation, but we right now we discuss it's was where to make such settings. Okay. Is adding to this channel? No? Okay. And what? And we have a document about this in the pad. Okay, a one page to show where are we and who are we. And right now we have plenty root server in Europe and in Asia. And now we are keen to find volunteer participants from Africa and Oceania to contribute more IPv6 owning root server to reach in our initial plans to reach to 25 IPv6 owning root servers in this testbed. Okay, before the workshop, I just do a little survey of what the current the status of our root service machine, OS system, and the software. And we're not required our operator to provide physical machines, and it's actually the practice done for the current IANA root server. Actually, as far as I know, the IANA uses virtual machine too, and their instance. So 3 out of 14 I use the physical machine, and most of other operators use the virtual machine. But that's the potential risk I will mention here is that virtual machine may some virtual machine may introduce some bugs receiving the fragment packets. I will introduce that later. And OS system, one out of 12, we are not collecting all this OS system. One used NetBSD, I think it's Ketu. Ketu-san used the NetBSD, and half of them used the Linux core with Linux core, different type of Linux system, and 5 of them used the FreeBSD. And the FreeBSD, in such case, the FreeBSD with the virtual machine, we received the bug reports from BI team and also from Y that experienced some fragment, some failures when they pull the root zone file from the authority server, from the DM. And we are glad that some of our operators use the latest the software, the DNS software to test, like the keynote here.
No bind 10?
Actually, one operator,
Carson's running.
Karsten,
He wants to do it by.
he wants to use the Bendy, right?
Yeah.
Okay. Yeah, they
We'll
want
set
to.
that up at the right meeting.
And it's a place to use the latest software, DNS software. We're glad to hear that. And also there is a bar reported by Usmek. It's about the keynote, right? And made some changes to current implementation. I will introduce that part.
Actually, the numbers do not match. There are
Ah,
12 servers here and 14
Yeah.
here.
I'm not receive the mail response from 2, so there's missing. But the virtual machine and physical machine got when they deliver their application, it contained the information. So that's for information about the machine, but select 2 response from about the OS system. I will keep sending mails to some operator. We are loosely connected, and there are ones that one root operator in India that is down for whole week. Yeah, we will notify the operator and ask for better services. But in the beginning, I think, especially before the DM setting up and ready for the experiments, we leave some space for the operator to learn how to run and to stick to some rules. Okay. Regarding to the reservoir, we do not have much of them, but relatively bunch of them, and we can see that one address contributes a lot of junk queries. There's NX domains, and in Yeti we still need to encourage more people to use our services and to contribute some experiment traffic. And I have to say that on the reserve side, we will not have the strict control of some measurements done to connect to the end-to-end performance end-to-end measurements. So, and I know that the first address sent a lot of traffic junk queries from Sydney, and I'm told that they're testing their new DNS software.
They are testing it's the development of the NOT resolver. Actually, it's a development of the NOT resolver, and there is one of the things that they test is to create a lot of random domain names and to try them, hence many NX domains. So it's one use of Yeti that we didn't think about using to test new software.
Yeah, that's one motivation when we started the project to encourage the vendors and the network device vendors and DNS vendors. And there's some traffic figure from DSC page. Our DSC page show the DNS query traffic in 1 week. And from the picture, well, it's relatively optimistic. But if you look at it in one month, we can there it's grateful. And we make a decision, make judgment that it's because they stopped the testing. So we conclude that now apparently the Yeti testbeds, most of traffic produced by our participant to test, it's not the real one. And oh, it's okay if it can fulfill its goal. I think it's okay. But right now, that's still a problem. If we want to do a large scale test to make more convincible evidence, we need traffic to reflect the diversity of network and systems, especially for the large packet size. And we will tell people that the system is robust. If the traffic is still low, it's not very convincing, I think. And also we talking about how to increase the traffic, invite more reserver to join us in the virtual meeting in the beginning of September. And there's 3 ways to introduce more traffic. One is that BI were talking to some universities and institutes to ask them to join our, just use our hint file to configure their recursive server and use in the environment office. And second is that proposed by the Mexico X team, and they replace some mirrored traffic to the system. And second, the third choice is to use some test tool to produce some traffic, like use the Atlas probes to produce the traffic query against them. And I think most likely to introduce part of it as a monitoring of testing methodology. And then I introduced this in September, and maybe not all of you know that we cooperate with one of university in Beijing. It's called Beijing University of Post and Telecommunication. It's a pioneer universities in CERNET that all the campus are covered by the research of the Yeti stack. And we test the feasibility of the Yeti concept to deploy the Yeti DNS and RDNS and configure the DHCP6 server to net the clients to get the recursive server point to the Yeti DNS. And well, it's now implemented one building and with a special Wi-Fi to make the student know it's a test. And well, it's contributes some traffic, but not too much. You know, that one recursive server only contributes less than one QPS, I think. But it's ready, and it's an example of how we encourage participants of university and institutes. Now we are approaching to other universities and institutes. Beijing Jiaotong University and the Academy of Science, the lab of Academy of Science also show their interest. And that picture shows the Yeti DNS traffic. I don't want to put much time on that. Okay, we built a small, just a DSA page, a system in Yeti, to show the statistics as we showed previously in traffic. And we also, in order to know the performance and the consistency of the system, we build a monitoring system just in BI prop to continuous every hours, we continuous checking the serial number, checking the DSC, the data they updated, and also the function of the root server. It's very easy to just ping the metrics. And I think one probably is not enough. Maybe we can deploy several distributed. And then before the workshop, we do a summary of the Yeti bars, and we saw most of them, and it's divided into several class. And one of the bars stem from the specification that when we start Yeti, we're not very clear about how to, for example, how the DM run to coordinate to keep the consistency and how to join. We just randomly join the root server into our system. So, but now we have a full the onboarding process and each step, and before each step there is a checking and double check by the coordinators. So I need to say a little sorry about that preparation. It takes a relative time to prepare that. But right now we are, well, right now it's sometimes it's the DSC page may broke, but we have a double at least two server to connect data. Uh, yes, if you are more interested about that, we can check the links of the related information. Okay, I will spend some time focused on findings and bugs during the construction of the testbed. As I said, Yeti use different name scheme, and we are not answer for the root server.net, the server.net Zoom, and we also not serve not authoritative for the upper Zoom. It's only answer for the root zone. And current implementation of the band and I does not include or glue of all the root servers because they are not assertive server for all the root server. So we use a patch for that purpose because we want to follow ANA's behavior. So there are related issues that upper zoom issue. We just cover upper zoom. Not cover. We can call it that it's served by the current IANA server, but not served by Yeti. And we also notice that there is unused glue issues. They are not actually glue address for the TLD, but we do not know why their address, the A and the quarter A address are there for some TLD and some as recalled. So maybe there may be some proposal to ANA to just to reduce the zoom fire by get rid of these screws, unused screws. And there's another finding in Keynote 2. Keynote 2, we found that it compressed the root, the zero length, but only with 1 byte. But in the RFC 1035 says the compression scheme allows a domain name in a message to be represented as either a sequence of label ending in a zero offset, or a pointer, or a sequence of label ending with a pointer. So the Keynote, well, technically right, replace the zero length label with a pointer. That is too bad. It's not ideal, but it's technically right. But it's introduced some error happened for some DNS tool like the Go version of DNSD. And now it's resolved, and we report this postmail. Thank you for your effort to report these bugs to Keynote Lab to reduce this problem, to get rid of the problem. And we also noticed that the current DNS cap, both DNS org and Verizon versions observed losing some packets, which is not ideal. I personally am not sure this process, what's the current status of this finding? Is it resolved or not?
So there wasn't any real appetite for serious research into this because it's not a core Yeti issue. We were able to find, in every case that we had problems with this, we found another tool which worked for us instead. It's a concern in the larger community because, of course, DNS cap is used for things like diddle, which are very important, and we make a lot of conclusions about the nature of the DNS based on this, which if the information that we're gathering is not correct, then we may be making wrong conclusions. So these are not things that are easy to reproduce. I don't know why. There may be bugs in network drivers or in TCAP libraries or in kernels or who knows. It's not easy to reproduce. What we may want to do is, again, this isn't really a Yeti issue, but in preparation before the next diddle, we may want to do some sampling TCP dump comparisons or some other tool comparisons and this kind of thing to verify the tool and decide what to do based on that. So that's kind of the status of that.
This is the first I heard. It would be helpful if you could share what information you have on that.
Okay. Yeah, we talked to Dwayne Wessels about it because he's kind of, as far as we know, the closest thing to a maintainer of this software. That's a separate issue as well. There's, as with many projects, if you go to GitHub, there's many to choose from. So we want to. I talked to Dwayne and I think William also at the DNS org meeting about consolidating this, getting it out of VeriSign and getting it managed a little better. So that will probably happen sometime before the end of this year. We'll hopefully get a new official home under DNS org's GitHub and merge in all the patches that we can find for that. But again, it's not strictly a Yeti issue, so it hasn't been a huge focus of it. But it is important, so we're gonna pursue it.
Yeah, maybe we can report to describe the error and the environment, what caused the error to responsible person on this software, and just let them know.
Yeah, there's two separate environments we found that there are errors. One is in Stefan's setup, which is on the NetBSD. Yeah, no,
Linux.
On Linux. Okay, and then we found errors as well on a virtual environment, I believe. So, I don't know if they're related or not, but yeah.
Okay. There are also some. Yes. We also noticed that some failures from root server on the root server transfer is closely related to our experiment and our system. The observation is that some authoritative server on some virtual the VPS failed to pull the zoom from the distribution master used TCP. I think the problem, I found two facts. One fact is that the TCP fails to respect the setting, the IPv6 use minimum MTU. Well, this draft is still alive, and you can check that. This fact is that many implementation of TCP running over IPv6 neglect to check this setting, this value, MTU value, when performing MSS negotiation. And when constructing the TCP segment, it will cause the TCP MS option set as 14440 bytes, 1044 bytes. But IP layer will limit the packets less than the 1028 byte. And the fragmented packet which results into the two fragmented packets. Well, it's a technically right, but it's just a performance concern issue. But another fact is that there are some bugs on the virtual machine software failing to receive such fragments. So the two facts combine together to introduce such failure. So this issue, performance issue, is already proposed to ITF. I think they may have in fact have some mirror down to some stack, some OS system, and this fact maybe well to inform some virtual. We found one example that free BST10 on the VMware EXIX 5.5. That's in the VR lab. And Keru-san also experienced the lab BSD in the virtual machine. Which type of virtual machine do you use?
Same. Yes, it's a 5.
Oh, yes, it's the same. So what we currently I think that there's maybe some some drive on the about the network drive on such kind of VM say the virtual machine is broken for this type of scenario, uh, but that we cannot do immediately to fix this part or this part. So our recommendation is that whether we can change on our server side, we can see the DM, it's a DM case in Yeti. In the DM, we change the MTU setting to 15 to allow more larger packet to go through the IP layer. Or we can recommend our client as the root server in Yeti case to set TCP MSS to 128 on the client side. That's the solution I come up with. Ketu, Ketu-san, now do you solve the problem?
Yeah, at this moment I don't see the problem with this workaround.
Ah.
The solution still, I have no idea because the MSS option and the IPMT stuff can conflict with the size. So
can configure.
Yeah. So
Okay.
which size that is it should use?
Yes. Because I propose this finding as very serious because we noticed 7 of our operators use the virtual machine, and FreeBSD or other implementation of the software on some virtual machine, especially VMware, we experienced that part, or maybe some recommendation not use this virtual machine in our test bed. Yeah, that's maybe another recommendation. Okay. Okay. And that's all for the my part to introduce the current status of the Yeti testbed. We start from May, and we set up a virtual meeting between participants of Yeti in September. Now we host the Yeti workshop now. Now I think most the engineer part of the Yeti testbed are already done. So as 3DM are running, more than 13 routes running, we'll increase that number in the following months. But now we lack of traffic, reservoirs, and end-to-end management. We also need experiment agenda we can discuss take this chance of workshop to discuss especially the second part of this workshop we will discuss some idea of experiments. Shan will give us first introduction of activity we've done on BI. And my personal point of view is that now we build this system, there's some experience we learned from building this and some technical findings. And maybe we can deliver some technical report to introduce our work in some technical bodies and standardization bodies to let more people to aware of our activity. Okay, that's all for my presentation. Thank you. Any questions?
can we switch to the slide where is architecture design? So here you have DM coordination protocol, and I think this one is the most. This one is a transparent part of the Yeti experiment. And is there any chance to be a peer for distribution master to participate in this synchronization, not to distribute, but just to understand the process?
Not to dispute, but only to do what?
Not to distribute data to another root servers, but to understand how you make synchronization for the DMs.
I'm not very sure about your idea. You mean this role of DM is not to distribute?
I think I can answer this.
Okay.
So, right now we have 2 documents in the GitHub which document the process. And as of yesterday, we're actually implementing that. I believe that the source code that BAI and Wide use is in the GitHub as well. Is that correct?
Each DM has a directory to contain their implementation.
So I don't know. I assume Paul will publish his pro or not.
Absolutely will.
Yeah. So yeah, it's available, and if you want to set up something like that on your own just to see how it works, then we can certainly work with you and help. Yeah. And we don't have any plans as far as I know. The coordinators can correct me, but I think there are no plans to add distribution masters. But if someone wants to run one of the distribution masters, then we can maybe talk with them, because that's less work for us. So.
I want to be a master. Okay, since we are on this slide, there is something missing on the right. The role of the NTIA is still there because we don't see what is the output of INR. We see the output of NTIA, which is the one which is reflected in frootservers.net. So even in Yeti, we use a namespace which has been vetted by NTIA.
Current in model, there is no such kind of role of NTIA. Actually, each DM play part of that responsible role to make sure the data is all right. As far as I know,
it's just a check, right?
Check.
Well, they can refuse the change,
but they can't change it. They can either refuse or not, right?
I think so.
I don't know.
I think so. But the route that we see, the one which is taken out of frootservers.net, is the one which has been checked by NTIA.
So there's a non-drawn line from the bottom of the left to the top of the right.
We can make some changes too. As far as I know, the IANA transition scope is to remove the NTIA's role, right? So we based the assumption that NTIA is already get rid of this picture.
No. No, as far as I know, in the process of IANA change, the role of NTIA won't disappear. What will change will be the oversight of IANA function, but I don't think that the US government is ready to relinquish the control done by NTIA today. Because the official mantra is that it's just a check anyway, it's not a problem, don't worry.
I have a question. Is there some mechanism to avoid some malicious modification of the INA zone data by the DM?
Yeah, actually, we just added a few weeks ago DNS check. So we validate the zone that we transfer from it.
So every resolver who have your Yeti DNS key can make sure whether the data is not correctly modified.
Yeah. Of course, people have to trust that we've done this step, but that's the nature of it.
Everything cannot be 100% be promised. And forgive me if I ask some very simple question because I didn't know too much about this Yeti project. And thanks for your invitation to let me attend this workshop. And the topic is totally interesting for me. And I just wonder whether Yeti is only focused on the IPv6 network.
Currently,
and
yes.
Do you have any plan to let some real resolver from the IPv4 network to use your root server and you can know well what the real world looks like and what is the real requirements of the
One purpose of Yeti is to encourage the use of IPv6, encourage people update their recursive side to use that at least, and it's experiment, research network. It's for some clear purpose. So at this moment, there's no such plan to. I need to give you the clear message.
So I noticed that you mentioned that the project is 3 years.
3 years duration, and with clear.
I just wonder why 3 years. So because of you think 3 years, there are a lot of real IPv6 resolver.
That was part of it. We thought that in 3 years, V6 would not be innovative. But also, we did not wish to be seen creating a semi-permanent part of the internet infrastructure. And what we agreed is that if the community then at that time wishes to extend it, then it can go on for longer. But that if nothing else changes, it will have been a project that had a defined beginning, middle, and end, which is rare on the internet.
Do you have some thinking that you will not only extend the time of the project, but also the resolver, not only IPv6 resolver, but also IPv4 resolver?
Again, I think we still have a bunch of work to do until we finish the goal to deliver some scientific peer-reviewed work. We're not changing the goal right now. Sorry about that, unfortunately.
Hi. Going back to the question about IPv4, it's surely arguable that if you wanted to measure the effect of middle boxes, that if you're only measuring that over IPv6, that you're not going to get a true picture because the IPv4 middle boxes will behave in completely different ways to IPv6 middle boxes.
I will give first response is that you mentioned the middle box problem. Yes, in VIS4 there are some legacy devices hinder some like the EDS0 and large packets and change with misbehavior. And as one of our coordinators, Kato-san, proposed that we invite the network device vendors to join. That's our hope and the goal to know the current IPv6 network can deliver better performance in that regard.
Yeah, I mean, it depends which middle box it's trying to measure. I mean, the middle box tends to sit between stubs and resolvers. In my experience, have vastly more problems than the middle boxes that sit between recursors and authorities.
One thing to reply to both of you about IPv6 and IPv4, Yeti itself is IPv6. It was intended this way. But everything done by the Yeti project is public, including source code, etc. So other people can set up other responsible alternative routes to test different things at what we do. Most of the people here in this room know that it's possible to set up an alternative route when you want to type it. Outside of this room, many people still don't know about that or believe that it's something black magic or something very difficult. One of the good things about Yeti is that it's also a way to have a description of an alternative route, what it is. So if you want to create one, you can copy the Yeti blueprint. And change things such as adding IPv4 addresses.
I don't think IPv6 only is on the Yeti constitution. The current operation is on IPv6 only. But if you think that the V4 middle box causes possible issues relating to the different configurations of built-in system, then that should be added to the experiment agenda to make sure that what happens. And encourage the middle box developers to fix the problem as soon as possible. So I think the V4, adding the V4 environment is not impossible, but up to the community's requirement. And I also want to invite as many middle box developers to the project, even if not actively, so that they fix the bugs in advance. That is my desire.
For one of the machines, one of the Yeti rootname server is hosted at Gandhi. And when you host at Gandhi, you can have as many IPv6 addresses as you want, but IPv4 addresses you have to pay, and the price is exactly the same price as the server itself. So running an IPv6 only machine is cheap and can be done by an ordinary student. If we need to add IPv4, we need a budget.
That's the actual scenario that we are, as our participant, that V6 and architecture and network easy to use without much budget involved. Yes, thank you.
I'm still curious about how often the DM fetch the INA data. If there is a
Every hour, 3 DM, from 3 time interval, 20 minutes.
20
20 minutes.
If there is if there is a situation that INA data is emergently changed, how can you get the INA data very soon?
We don't guarantee that.
So that means there is a bug that there will be some difference between INA data and the Yeti data.
Keep in mind that it takes the current root servers 20 minutes to get the new serial to all their zones anyway. So since we're getting it every 20 minutes, we might have an additional 20-minute delay, but it shouldn't be.
You cannot change things in an emergency in the root anyway. One of the reasons being the cache of the resolvers.
Yes.
Because there is no way to tell all the resolvers on the planet to flush when there is a change. So for instance, introduction of a new TLD, something which is trendy these days, cannot be done in emergency. And it can be a problem in some cases. For instance, a typical problem is people have an issue with DNS sec. For instance, the key was compromised and they have to change the DS in emergency. Well, there is no way currently, even in the INR route, there is no way to do so. And it's a big problem. But Yeti is not worse in that respect.
And as far as I know, the DNS system is loosely connected. I mean, in different domain, different delegation. People tolerate some latency about the updated. When you apply for a change to your AS record or a new IP of your server, you must wait for at least 1 day or several hours at least, I think. So current situation is that the DNS system is tolerate for some delay. And as Shane mentioned, that the current INA system has 20 minutes at least to update all the systems. So we're not focused on the accurate or the optimization of this performance according to the real purpose.
If this is a problem, we'll change it to 1 minute. We are not going to allow this to stand in the way of the usability of the system or whatever it can teach us. So we're not stuck on 20 minutes. We're doing 20 minutes now because we're trying to get this thing rolling.
I'm not for it, but I'm not this out.
Okay, that's all. No questions? Okay, next one, Shane. You have 5 or 10 minutes to give some feedback
Really quickly.
when you participate in the meeting.
For this next section, I don't have slides. I just wanted to give a really quick feedback because I was at the ICANN meeting in Dublin 2 weeks ago, I think, something like that. And I don't normally go to ICANN meetings, so it's always very stressful for me to do such a thing. But this one I ended up not hating, which was good. So as part of that, I talked to a few people who were on the KSK role design team. Because I'll talk about this later, and that was interesting. But as I said, I do have slides about that a bit later, so we'll go through that just so you know. Another thing that might be interesting for Yeti participants is that there is currently an ICANN study that just got initiated on expanding the number of domains in the root zone itself. Because the idea with expanding the root zone was to have an initial expansion, check to make sure that it was okay, and then proceed on with further expansion. So we're in the kind of pause where we're supposed to be checking, but they haven't actually started checking yet. But that's about to start. And I think the idea there is that this is an anticipation of further growth. But so we're actually kind of at a nice quiet time right now. And the final thing that I wanted to mention here is that there was a meeting between RSAC, which is the Root Server System Advisory Server Facility, I don't know, some root server people and the ICANN
Root
board.
server system advisory committee, yes.
Yes, there we go. Are you the chair of that?
I'm one of two co-chairs, yes.
One of two co-chairs, yes. So you will correct me if I say something wrong.
No, I won't because I'm asleep.
Good. So I was just there mostly to see what was happening, but one of the new ICANN, I think he's a new ICANN board member, asked about the number of root servers that we have, because apparently this is something that he and other people at ICANN are interested in. So I took that as an opportunity to introduce the Yeti project to any RSAC members who weren't familiar with it who were there, as well as any ICANN board members who weren't familiar with the project who were there. And I think, did you send the minutes to the discussion? Yeah,
send 2 minutes to discuss minutes.
Yeah, so Davey sent the minutes to the discussion list. You can see the actual text that
And
went
those
on there.
mail already.
That was a bit of a
Thank you very
surprise
much.
for me. I'm used to meetings that are recorded and stuff, but I'm not used to meetings that are transcripted and documented. It feels very official, like I went to some sort of court. Yeah, exactly. But yeah, Steve Crocker was interested in who was doing it, so we're transparent. We have so far nothing to hide, and I think that was about it. So if you have questions about it, you can come and talk to me. It was generally very positive. I think people were surprised and interested to know that this research is going on, which is kind of good. That's it.
Okay, thank you, Shan. That's all for the first part of the workshop. We have 20 minutes coffee break. There are coverage service inside the room and outside the room for some drinks and some fruits. Okay, enjoy it. Thank you for the speakers for the first section.
And the others are just the key information for signing this one. So that's it. And as I said before, as of yesterday, this is actually working, and it's pretty cool. And we shouldn't have any more problems in the future about mismatched zone files. Next slide, please. So that's how we get the information between the distribution masters. How do we actually generate the zones? This is also documented in a separate file. So this is just the detailed list of the changes that we actually make to the zone file. So we get the zone, as we said, from the F-root server right now. We found it to be the fastest, although I think ICANN has given us information about the way that they say is the real fastest way to get this information. We may change our things. It's not super important, but we do get this information. And right now, the BII server will check the DNSSEC signatures of this using the trust anchor, which we downloaded at some point. Because the zone is signed, it's not a super important step because a resolver should validate it independently. But anyway, so we update the SOA slightly we leave the serial number the same, but we update the contact information and stuff like that. We take out all of the DNS signature information from IANA. We remove the IANA root servers, just the NS records, we leave the A's in, doesn't matter. And then we add our own DNS keys, and we add the Yeti root server information, and then we resign it. So this is, you might be able to tweak this a very small amount, but this is basically the minimum set of changes you need to do this operation, and that's what we want. Right, so this is, so that's how we manage the servers, the masters, the distribution masters today, how we manage the root zone. So what were we thinking of for our first experiment? Right now we have these 3 distribution masters, and they all share the same KSK and ZSK. And this means that we all have to have the same private keys for everything. And there's no split in roles like IANA and VeriSign. I didn't put NTIA, I guess I should have added that there as well. But we don't have that kind of split in Yeti right now. And having this ZS, if we were able to separate and have different ZSKs, that would kind of increase the independence of the DMs. And so that's a goal, is to be able to have different ZSKs for each distribution master. So next slide. So some of the folks at BII, Davey, organized this work, put together a lab test, and it's a pretty basic setup. We still have a single KSK, which is what you'd expect, but then we have two root servers in this. These are not distribution masters; these are actual root servers, and they have separate ZSKs. So A and B. They may be the same, they may be different. Then we have one resolver, which uses a hints file, which points to those 2 roots. The idea is that this is just a closed lab, and that's how we ensure it. Then we did the test with both bind9 and unbound resolvers, and saw identical results, which were as expected. So the actual experiment, we turn off the B root. That ensures that the resolver goes to the A root. And then we let the resolver do its priming. And then we do a query, and we check that it validates, which you would hope. And then we turn off the A root and then turn on the B root so that all queries have to go to the other root server. Then we query another signed CLD, and that should also validate, even though it has the cached DNS key records from the other root server. So that's the whole experiment.
If we queried jump, not to jump query, they will not catch, right? If we just use a jump query, it will not be cached by the result.
Right. Okay. So with that experimental setup and that experimental procedure, we have a few different test cases. The first is where we actually use separate ZSKs, which are not shared between the 2. The other one is where we use 2 ZSKs that are shared by both. And then to add a little extra excitement, we did the key roles also and check the behavior of that as well. Using both of the documents, standards ways to roll your keys, pre-publish and double signature. So the results are basically what you would expect, which is good, which is that when they have two ZSKs and they're not shared, you have a serve fail because you have a cached DNS key record that doesn't match the query that you just did. So, but if they're shared in any way, then it works, which is great, which is what you would expect. So just, well, put a lot of small characters on the screen. This is a sample response. It's very difficult to fit all the data here, but basically, this is the response from the pre-published one. The response is fairly large because of all the keys and signatures, but it's totally normal DNSSEC traffic. Everything works as expected, and I think that's it. So it's a bit of a boring presentation here because it's a conformational lab test as the first step here. And what we discovered too, which is really nice, is that everything works exactly as that we expect, which has not always been the case in the Yeti project, so it's nice. It's important to do this kind of work first. We still have a little more work to do before we run it on the actual Yeti platform. And the first is to do some impact analysis. You saw that packet was far bigger than 512 bytes. Well, actually, it's IPv6, it doesn't matter so much. But
yes, I want to add something that we assume that the set of the DSK can be contained and cached by the resolver, and we are not sure is about if there's any limits of the size of the setup key. So we test unbound and finds with various number of DSK. That's the only case of two root server. We use 13. You can imagine how large the back package is. Right. So it's no limits on such kind of set of key. Exactly. So we need to pay attention to the impact, the packet size.
Yeah. So there's still a little bit of work to be done looking at packet sizes and the effects that has on the behavior. And my own thinking is that we will also not find any surprises there as well. I think everything will work exactly like we expect it to do. But I'm happy to be surprised.
Yes. Yeah, I also need to add something that we're not only at two different keys, same algorithm, the same length. We actually use a totally different key management policy, right, to enable the different DM. I think in my proposal I introduce the case who use the different algorithm with different key names.
Yeah. I'm not a huge fan of that. Yeah. I want a single variable if at all possible. David wants to look at all these interesting things, and I want to just make a single test at a time. So we'll have this discussion, I think, and probably beat each other up. And then hopefully before too long, we'll have finished this, and then we'll actually make a sort of a semi-formal proposal about the experiment to run on the platform. And what this will mean, though, is that we will be putting different ZSKs on each of the different DMs. Each will have their own separate ZSKs. And we may do it in stages, like add 2 and then 3, and then see what happens in this kind of thing. We have to work out the details, but that's the basic idea. And we need to define which measurements we're going to do before, during, and after such additions, and then how we report this. So those are the details that we have yet to work out. But I think this is a really good candidate for our first formal experiment. And I think the guys in the lab have done pretty good engineering and can get it all sorted out. So, yeah. All right. So speaking of ZSKs and KSKs and things like that, this is a bit of a non-experimental digression. But since we're kind of talking about this area, I wanted to talk about the ICANN plan for the KSK role. And so for those of you who don't know and aren't familiar with this, right now, the idea when the root zone was signed, there was a DPS, a DNS practice statement, which included a whole bunch of information about how the zone was managed, as well as saying, they would roll the KSK every 5 years, or if there was a problem. Well, I think as of this month, it will be 5 years, and there's currently no strong plan to roll the KSK. And the issue there is that we don't know what's going to happen, and it's really scary because we don't know who's using the key, and we won't know when they've rolled to the new key. There's an algorithm designed to solve this, which is RFC 5011, but it's not implemented everywhere. And even places where it is implemented, it's not always deployed because a lot of administrators are very uncomfortable with software automatically updating configuration, which is especially trust tankers. And places may have regulatory or other policies preventing this kind of automatic stuff. So basically, we don't know what's going to happen when we roll the root zone. So ICANN has a design team. I don't think any of them are in the room, but they have a design team to look and think about how to solve this problem. And they published a plan, the ICANN KSK roll plan, I think like 5 months ago or 4 months ago, something like that. And they had a comment period. And I talked about it with a few people, and I think we mentioned it on the mailing list, I can't remember, but I think Stefan also returned feedback. I returned some feedback myself. I haven't heard back from the plan yet. ICANN is very process heavy, and they will get back to everyone who returned feedback and let them know what they thought. And my basic concerns with the plan were that it had novel characteristics, by which I mean they were doing new stuff which has never been done before on the internet, and you're doing it for the most sensitive and dangerous, risky thing that you're doing. And so you're inventing a new process in principle to lower the risk. But of course, as you know, anytime you do something that hasn't been done before, that carries certain risk on its own. So the things that I considered risky, well, the reason they did it this way is because they have this DNSSEC practice statement, which has very strict timings defined for when things can happen. There's a ZSK roll, I believe, every quarter, and things happen every month during that time, and things like that, every quarter of a year on you. So the plan that they presented ensured that they would follow this practice statement. And I think that's a bit unnecessary because a practice statement is just a document and you can change it, especially because you're not going to meet this 5-year rollover time that's already in the document anyway. So the other thing that was input into their plan was they have a very, very great fear of large packets. There's a huge, huge concern that if packets get too big, really bad things are going to happen. I think that's been lessened a little bit recently because of some of the measurement work that's gone on. I know Jeff Houston did some measurements specifically for this. He's on the design team. But it hasn't gone away completely. And part of that fear is probably justified because we don't know what's going to happen. But on the other hand, the precautionary principle, which says that if you don't know what's going to happen, you should be cautious, doesn't mean that being cautious is the best way forward necessarily. So what I looked at when I saw this plan was that the roll was going to take a very long time, and also that they did some strange things in order to minimize packets. So, for example, you put in a new KSK, you remove the old one from the DNS key set, and then later you reintroduce that KSK in order to set the revoked bit on it. Now, in principle, that should work, but it does seem a little bit counterintuitive, and I'm not sure exactly what would happen if that sort of thing happened. At the very least, I can imagine that some administrators would say, why am I getting this new strange key? I haven't seen it before, and it has this revoked bit set. What's going on? So I thought it was very strange, and that was kind of my feedback. Now, regardless of my own personal feelings about this plan, it was, in my mind, a very high priority for Yeti for a couple of reasons. One is that if we want to do a KSK roll in production, it will take at least a month because RFC 5011, which is this way to automatically roll the key, has a hold down timer of 30 days, I think. So you can't roll a KSK any faster than that. So in my mind, it was a high priority, partially because it was going to take a while to test, and the other reason is that the ICANN design team was hurriedly moving along, and they might be starting implementation plans soon. Having talked to a few people on the design team at the ICANN meeting, I'm less concerned about it because it doesn't seem like the initial plan is actually what's going to be implemented. The people that I talked to seemed like there was still kind of brainstorming and searching for ideas around this area right now. So I don't think ICANN actually has a plan right now for rolling the KSK. I think whenever they give us feedback on their initial proposal, which hopefully will be before the end of the year, I don't really have any way to know, we can look at it again. And maybe that will also be an interesting experiment for Yeti. Right now, basically, we're just waiting. I think what we can do instead is do an experiment where we roll our own KSK using a normal, like double DS methodology or something like that, just a normal roll, and see that works. So at least we can give that feedback and say, these standard mechanisms, which are already defined in DNSSEC best practice documents, do work. Or we may discover they don't, which is also interesting and terrifying. So anyway, that's it for the ICANN plan. Next slide. All right, so this, as I mentioned, we might want to do a roll for Yeti. We actually did try this once already, not as an experiment, just kind of operational practice, because you roll your KSK, that's what you do. And it failed, which is interesting. And the reason we think is that we didn't take into account this hold down timer, this 30-day period. So we rolled faster than that. What happened is that by9 worked fine. By9 does not implement this hold down timer, which technically is a violation of the RFC, and Unbound does respect it. So what we saw was that some people's resolvers stopped working, and other people's resolvers didn't stop working, which is great. So we're actually going to write this up as a short document. I don't know if we'll publish it as a informational RFC or just as a Yeti document, or I don't know. But we'll write it up so that people, at least other operators, may be aware of this risk and not have the same problem that we did. So the next time we do this, we'll run it as an actual experiment. We now have a protocol for this. We can actually define what we expect to happen and things like that. Run it in a lab first, the whole thing. And as a related, somewhat related to the whole KSK role issue, is that Jakob, I can't pronounce his last name.
Jakob Schlitter.
Schlitter, yes, anyway. He was on the ICANN team that did the original DNSSEC practice statement for the ICANN route. And he asked us, just friendly, asked us if we have such a thing for Yeti, and we don't. So I looked into it, and it's not an impossible task. There's an RFC, which gives an outline, a template that you are supposed to use for your DPSs. The motivation there is that it will make it easy to compare practice statements between different operators. Really, the target user of this format is TLD operators, basically, or people with other very high-value domains that need to be transparent and have good audited security. So it would be a lot of work, not a lot, but it would be a non-trivial amount of work for us to do. And I don't think there would be any real gain because we're an experimental network, and anyone who's expecting any kind of, the document would read like, we have no plans for emergency if our building catches on fire. We have no HSM. We have none of this. We don't do that. We don't do that. It would basically be a big waste of time for us to put together 20 bullet points which say we don't do any of it, just so we could document it. So as a proposal instead, what we might want to do is just put together a document which says we don't have a DNSSEC practice statement because we don't think it's worth it, just so people know that we did think about it and that, we're not doing it. And if anyone who has expertise and is interested, I'll be happy to work with them. I think we can safely say we're not opposed to it, we just don't think it's high priority. Right, another somewhat related thing is hint management. So right now, it's not a real proposal, but one kind of crazy idea that someone, that I think it was Jeff Houston had, was that since it's really, really hard to roll the KSK because we don't know what's going to happen, let's just create a new set of numbers served by the same root servers that has a new KSK on it. And so that we don't actually have to roll anything, we just set up a new one that has the new service, and then we can, in the new world, we can be sure exactly what's going to happen. It doesn't solve the problem of getting rid of the old KSK, but it does solve the problem of safely introducing a new one. I'm not sure that's a great idea, but it is interesting. And of course, I don't think it would happen in reality, because once you start introducing new numbers, then of course, anyone who wants a new root will say, well, why do we have to give the new number to the old operators? I can do it. So it probably won't go very far. But I thought it was interesting, and it kind of fit in the whole thinking about how you manage these hints about the root servers. So another thing that was related to this was there was some research on the old JRoot. I think Dwayne Wessels presented this at the last DNS org, and they're still receiving queries because they didn't turn down the address. They just kept it up and kept receiving the packets, and they're still receiving packets. And it's if you have time, it's a very interesting presentation if you haven't seen it. It's the nature of queries is actually different than the ones they get on production, but it's a lot. It's like a third as many queries or something like that. Yeah, I don't know. It makes no sense to me, but that's it. Other root operators who have renumbered have turned down their addresses, and a lot of them don't measure this, so they could still be getting queries on those addresses, but we would never know. So anyway, Davey was thinking maybe do we need protocol support for this kind of renumbering and things like that? And I said, well, we don't really need that because we have the priming query. The protocol support is actually already there. It's just a matter of updating your hints.txt file or whatever you call it, named.cache or whatever. So when you start up, you have the correct information. So I thought maybe what we could do instead is just automate that process. Oh, I'm seeing scared looks in the back. Well, so what we've done so far is we've written a simple script which will do the priming query, compare the results to the old hints, and if they're different, it'll swap out the old one, save it, and then put the new one in place. We don't have it set up to send an email, but that's pretty straightforward to have. And so the idea is to possibly propose to include this with bind and unbound and things like that. But Leon wants to say how what a horrible idea this is.
May I comment?
Yeah, please.
Lars Lehmann from NetNode, co-chair of RSpec and also operator of iRoot. The one reason that I've always seen to not do this is that if you end up in a situation where someone feeds you with bad hint information, is that you shouldn't perpetuate that on your hard drive. So next time you reboot, you start from bad data, you never get back into the loop again. Then again, if you actually do validate this, then if you add to that another bullet that says first validate.
We do validate, actually.
Then I'm happier. Or less unhappy.
Yeah, we validate the query. We can't validate the name. We can't validate the names because rootservers.net is not signed, but we can validate the priming response. So that's what we do.
Currently, that's very good input to the another discussion that we have regarding signing rootservers.net or not. So thank you for making that obvious to me. Thank you.
That's
I'll go on, Dave.
Yeah, I just want to ask a simple question. Current IANA system have not signed the root socks,
rootservers.net.
Yes, so that's maybe a requirement to ask this report and then implement this accordingly. Make sense.
So as always, DNSSEC solves almost all of our problems.
If you use it.
If you have a
and again, the motivation here is just so that we can safely renumber and not have to have systems that stay the same forever. Now, the path to get there would be quite slow because getting this, even if next week I sat down and was able to convince the people who at ISC and NLNet Labs and PowerDNS and Microsoft and everyone to include this in their software, then I'd have to sit down next and talk to the people at Fedora and Debian and Arch and FreeBSD and NetBSD and does Solaris still exist? Anyway, to get it in their distribution. And even then, there's people on CentOS 4 who will still be using their software in 2019. So yeah, it would still not help in the short run, but eventually.
So I'm skeptical that it will solve the problem of all Gaywood, because these queries that still arrive after 10 years, are they only priming queries or ordinary queries? If they're priming queries, it's not a problem because it's only one, and after that the resolver has a new address. But I suspect that they are not priming queries, but ordinary queries, and the resolver is more broken than that. And so probably a resolver which is broken enough to not do priming properly, probably won't be updated to validate with DNSSEC, update the ints, etc.
I'm pretty sure that you're right. It is a lot of other queries, although I think Dwayne discovered that most of the queries from some of the resolvers were priming queries, which is weird. Like they were querying several times an hour type thing to a single root. But you're probably right. On the other hand, I think if you can establish it as normal practice to do this type of operation, as far as I know right now, you basically have to wait for the new version of the software, or if you're on a Debian, the maintainer will update this for you and things like that.
My experience is that it's not even sufficient because people copy the old configuration file from one system to the other. Last time I measured the amount of traffic coming from source port 53. It was still by far the most used of source ports. So there has not been a program with a default setup of source port 53 for many, many years. So apparently people upgrade bind, but they copy the old named.conf with old query source address 53.
Yeah.
So I think Bill Manning also had the trace of the very old mroot address, which only survived on a few months. He still sees the track, but I tried to contact him. I wrote the email, got nothing. But the analysis of the traffic data may be able to give you more slightly better understanding.
Possibly. I think even though this Yeti is a research project, it's not strictly related to Yeti. It just kind of came out of latest stuff. And my goal with this is not so much knowledge and understanding as much as fixing problems. So.
Yeah, as I alluded to earlier, there's a particular piece of malware. The binary dates back, I think, 8 or 9 years now. It has a hard-coded list of, from memory, 11 root server addresses. It doesn't have the two that are associated with the US Gov. And of the...
So you're saying they came from the NSA?
No, I think they just didn't want to actually trigger any alarm bells of those two particular root server operators. But even a couple of years ago, 2 of the 11 that were remaining were for root addresses that's changed.
Well, I don't know if I care about malware operators updating their software.
No, but it's another interesting source of continuous traffic to the old roots, because this particular piece of malware has built a resolver that does talk directly to the root operators.
So I think we all know how to use DNSSEC to verify a parameter response well enough to decide whether it's more or less credible than whatever we've got on our hard drive now. And we can certainly build a system like that. And we might even be able to get complete coverage in all of the DNS software that is shipped after that date. However, I don't think the long tail we're seeing is from software that's been deployed in recent years. What the traditional long tail mechanics, at least with bind and other open source type software, is that if it's ever going to be updated at all, once or ever, if it's going to get more than 0 updates in its lifetime, it will get them every year. And the rest are not coming back. They're going to, this long tail that we're seeing right now cannot be solved with any update we'd like to make to software going forward, nor will the software that is going to be made otherwise going forward have this problem. So At the moment, this is, seems like a solution looking for a problem, and I think we have more important ones.
Well, I'll probably be pursuing this anyway. I like windmills, so I will happily tilt at them. But it won't be, as I said, it's not strictly a Yeti issue. It's related. All right, next slide. Another related piece of work is fragmentation. As we know, failed fragmentation is very expensive, and by failed fragmentation, I mean a recursive resolver doing a query at an authority server who has to fragment the results, but then some horrible middle box in the middle does something bad, either munges the packets or drops part of them. And what this ends up causing is timeouts on the resolver level, or retries in the case of you do DNS probing to try to find out the right size, which is very expensive if you're doing it in this kind of timeout-driven fashion. So one of the engineers at ISC, Sivamaran, had an idea to do the fragmentation in the DNS packets themselves, and not rely on the IP layer. And so we thought it was interesting, Davey and I. Davey pointed it out, and we said, oh, that's kind of cool. So we built a proof of concept proxy implementation. It wasn't too hard. It was my first experience with Go, and there's a really cool Golang DNS library, which basically made all this quite straightforward to do. So we implemented that, and we worked with Mukund to put together oh, that's the wrong URL. That's a related draft. But, I'll update the slides and put the correct URL. Sorry, I copy pasted the wrong thing. But there's a separate draft talking about fragmentation, and Doc talks about the various issues. Of course, it's not straightforward because you have to decide how big the fragments are that you're going to send back. How do you make sure that support works? How do you avoid amplification issues and things like that? So we looked at all that in there, and it's documented. So we have a to-do list of things left in that document. So there's still more work to do, but we're not gonna. I don't think we're gonna ask for adoption, but I think between this ITF and the next one, we're gonna ask for adoption. And let's see. So one reason we mention this in the context of Yeti is because we are doing experimentation with larger things that will cause larger packets and things like that. Another reason is that we actually have this proxy deployed alongside our route right now. It's on a different port, but so the idea is that we can do testing with it. So it would be nice someday in the future if we could do experiments with this technology, but I have a hard time thinking of a good way to do that because it involves changes on the resolver side. It may be something like we would ask root operators to run the proxy next to their server, and if they do, to publish that, and then we could run probes using write atlas or something like that. I don't know, or write our own custom measurement network. It might end up being a project that isn't a Yeti research, but relies on participants in the Yeti project to help us do this research. Because for us, the interesting questions are, what is going on in the internet and how's that going to affect it? So, and we already talked about middle boxes in V4 versus V6 earlier, so my guess is that it'll be cleaner in V6, but there will probably also be a lot more bugs that get triggered in V6 because it's untested code, so we'll see. And just a final note about this fragmentation stuff is that for those of you that are following, there's a work in the DNS privacy area about putting DNS over DTLS, which is the datagram TLS. So it's UDP version of TLS. And one of the problems with datagram TLS is that, of course, it makes the packets bigger. And so this was flagged as a problem. So the author said, oh, well, we could just fragment in the protocol ourselves, which is basically the same problem and the same solution. So they put parts of the work that we've done. They didn't know about our work, and I'd only discovered that they were thinking about this later. So they have a kind of similar version. In spite of what patent attorneys think, when you're an expert in the field, there tend to be obvious ways to do certain solutions. So it's basically, here are the number of packets to expect, and here they are in order. and then there's issues about how many do you send and things like that. But they're missing a lot of the nuances because that was actually the problem that we were trying to solve, not just something that was getting in the way of our cool encryption solution. So I'm hoping that we can meet with the authors this week. I suspect that they won't want to reference our draft because we haven't been accepted as a work by any working group chair or any working group yet. On the other hand, I think it would be a shame because it's not really core to their work, and there's a lot of issues there which they haven't addressed. So I don't know what's going to happen with that, but it's kind of interesting. And of course, an answer to all of this is just use TCP and don't worry about it. But that's not the world we live in, and hopefully we can help optimize UDP with this technology. So, all right, that's it for fragmentation. Next slide, please. Is that it? Is there more? Is that it? Okay, that was it. That was the end of my
Okay.
Yeah.
Any questions or comments?
Lars Lehmann again. We did this. Dave and I talked about it during the break here. I would find it interesting to see the results of the experiment, either run by you or you can tell me that it's already been done, but to force the entire population to use TCP all the time, just to see what happens.
That is an experiment we want to run. So when Shaw actually put together patches for bind and unbound, Power DNS.
Power DNS.
I don't put Power DNS patches.
Power DNS has the setting.
Well, but we had to make a one-line change to get it to
Yeah, but I don't make it to a GitHub.
We haven't published it, but you made the changes so that they always truncate the answer.
Right, thank you. That's
yeah.
The seed is already in your mind. That's good.
Absolutely. I'm also very curious because I love the idea of TCP DNS. I'll be very interested to see what happens. And maybe it'll all collapse, which is useful information.
Absolutely, yes. I'm totally on your side.
Yeah, on the other hand, there are two things that we have to keep in mind. First, that today implementation of TCP are not optimized, so it may work, but with problems that we have to set up a TCP session for each request, this sort of thing. This will be solved with RFC 15966 bis. So when it's implemented and deployed.
Yeah.
And then today there are very few Yeti resolvers, and most of them are managed by people who are interested by this sort of thing. So typically they have a clean network with a proper middle box, this sort of thing. So even if it works for us, I mean the people who have a Yeti resolver at home, it may not work so well for everyone. So it's still an interesting problem.
So I'm just going to answer that and then I'll get to you. So one of the things that I want to do is, in order to, it won't help us in terms of diversity of resolver implementation, but it will help us in terms of diversity of network, is that I want to get Ripe Atlas to be able to take an alternate hints file for a set of queries so that we can actually run the experiment on this awesome distributed network probe. I don't know if that's going to be possible. We can simulate it by sending first a query, getting the answer, and then sending a TCP query. It's possible to get similar results, but ideally we could convince Ripe NCC to actually do this for us.
It will be difficult because the Atlas doesn't have a full service resolver, just a stub resolver. So it relies on the resolver of whatever is given to it by DHCP. So
no, there's options for this. I think it
no. You have a DNS client, which is not the same thing as a full service resolver. So you have a DNS client, so you can send DNS requests. But you don't have a full service resolver. For instance, if an Atlas queries a Yeti root server and receive a TC, it won't retry. It just sends the DNS request and sees the reply. That's all.
You have a dig. You have a dig equivalent to the utility dig, more or less.
And you can use it in user-defined measurements?
No, you don't have the utility. What you have the options that you speak of are similar to what you can do with dig.
So the Atlas retries? I will have to test that.
I think there's
you are probably quite right because you work so much more with it. So I was just trying to
But this is something to test on,
Yes.
maybe to request from the YPNCC. But remember that the Atlas has very limited hardware resources.
The new ones are good.
Yeah. I was actually going to suggest for you to talk to our Czech friends with the terrorist project to see if that's something where you can sneak in.
Do they do measurements with that, or is it
Yeah,
just?
yeah, they do,
Okay.
to some extent, at least. So at least talk to them.
Okay. Yeah. Yeah. All right. Cool. That's it.
Okay. Okay, thank you, Shane. So next one, Stephen, your turn.
Can I use my computer or your keyboard so I can step at will? Or can use
you
my
can
computer?
use yours and to post to, and I will help to play to the remote participant. It's okay. I just follow your slides. It's okay. Here we go.
Mhm.
Strong.
Hope I didn't destroy anything. Voilà. Okay, I think we will have to use your PC. I don't know why, but no signal is sent.
Do you need any edits to your
No,
previous?
just
Okay.
it's not a big problem.
It's the same.
Just turn it so I can use your keyboard.
Okay. Okay.
Many steps.
Well, I had a presentation where I came
Sorry.
the break beforehand, made sure everything worked, and then it didn't work.
Yeah, that too.
And so let me check the GoToMeeting setting. It's okay to post the second screen to. Okay. I think it works. Okay.
With this.
Yeah.
Okay, so up. So of course we are not a production network, we are an experiment. So we don't have SLA or things like that. Nevertheless, we should try to produce a service which is as good as possible, because any problem can be the sign that we have something to fix or something that could be better, etc. So it's, even if we are not a production network, it's still useful to monitor and measure Yeti, and we already have in the first months of the project several problems, broken servers, etc. So it's an opportunity to find new things, new problems. Today, as far as I know, it's not completely true, but at the beginning of Yeti, most of the testing were done by hand, by people using dig and say, okay, the server seems to work, that's fine. It's a bit better now, but at the beginning, it was quite manual, and it's of course not sufficient. So first, on the monitoring front, we need to have more monitoring, both by the coordinators or by other people who want to see if Yeti is functioning properly. In the examples, I use Isinga as the monitoring platform. For those who don't know, Isinga is compatible with the Nagios plugins. Now the monitoring plugins don't sell Nagios plugins because now it's a trademark, and you will have a lot of lawyers against you if you say so. So now it's monitoring plugins, and they use the same API, so any software compatible with Nagios can do it.
Which is trademarked?
The Nagios company now enforce the trademark, so if you call it a Nagios plugin or Nagios compatible, you have problems. And they even hijacked domain names nagiosplugins.org, which was managed by the community, and now it's managed only by the company. So we had to set up a new software for the repository of community plugins, which is monitoring-plugins.org. But technically, it changed nothing. So, among the existing monitoring plugins, the good thing about Nagios or Nagios compatible, for the people who don't know, is that there is a very simple API. So writing a script to do testing is something very simple. You can do it, any student can do it. And also, because of that, there are a lot of monitoring plugins maintained by the community, and most of them are good quality. For instance, there is a checkdig, which can perform a DNS test, not difficult because actually it's a shell script calling dig, so not very difficult. But you are also not in the official monitoring plugin distribution, but in some country repositories, you have stuff like check DNS SOA, which check a zone and flag if there is one server of the zone which is down. So it's a different point of view. You don't test a server, you test a zone, and you define how many name servers need to be down before there is a warning or a critical alert. So it's very convenient when you want to monitor zone, and because if you test each server, you can have a lot of alarms which are not so important. So typically, error on the zone is more important than error on an individual server. And you have also from Dwayne Vessels, check our SIG, which retrieves the DNSSEC information, the signatures, and tests if they are soon to expire. As with any monitoring plugin, you define what is the delay that you expect. So typically you have a warning when there are only 3 days left, and critical alarm when there is only 1 day left before signature expire. At the beginning of DNSSEC, by far the #1 reason for problems in DNSSEC zone was signature expiration. Now that most people automatize signing and re-signing, it's less a problem, but it's still a problem. So it's very cool to have this to check your zone. And this, in my opinion, this is the sort of thing that should be done in some platform common to the Yeti project, managed, for instance, by one of the coordinators or by someone else, because and then it could be exposed to the rest of the world through the web interface of Isinga, Nagios, Zabbix, etc. So people can check automatically the status of the Yeti route. And also Wipe Atlas, I will mention the Wipe Atlas probes longer, but one of the cool things that Atlas can do now for only a few months, it's to, you can have a permanent measurement doing periodically, and you can retrieve not all the data of the measurement, but only the current state of the machine which is monitored, which means that you can do a very simple REST request to Atlas, and you can have the current state of connectivity of a machine. You define how many failed probes do you accept before declaring that it is a warning or critical. And the good thing is that unless the ordinary check ICMP test of the monitoring plugins, it is done from many points on the internet, which is very important because today most of the reachability problems, especially in the IPv6 internet, which is in a very lousy state, most of the problems are not specific to one point. If you measure always from the same point, say your network, for instance, you may think that it is okay when actually half or 1/3 of the IPv6 internet cannot reach you. That's why this feature is really, really cool. And it's not yet well known because it's recent. So is it an example of what we do for the root name servers of the DAO group. Here we use checkpig and we declare that if the RTT is over 200 milliseconds or if there is more than 20% packet loss, warning and critical when it goes to this point. And we test the DNS, check dig, IPv6 only, of course, because the Yeti is IPv6 only. We test the root. We ask for the SOA, some options, and then if it's not okay, we have a warning. One point here is that it's surprising when you use ordinary tools to test a DNS root. A lot of tools were not prepared to do that on break when you use .dot as a domain name, for instance. It's incredible how many tools are broken in that respect, probably because there is only one root, they are already managed, and most people test ordinary zone, not the root. But here it works. Dig can work fine with .dot as a domain name. Here the same thing with the tool used to check SOA of all the name server of the zone. Here I define the group my zones with things like afnic.fr, nic.fr, etc. And here we check the signatures on all the zones in the group. And if there are only 5 days left, it's a warning. 2 days left, panic, do something now. It depends, of course, on the parameters that you decided on in the OpenDNSSEC or something like that configuration. The biggest problem with this script is that you can use only full days. Yeah, you cannot say 12 hours, for instance. So, well, if someone knows Perl, it can be improved.
Do you ever want that fine grain for your signatures? I mean, honestly, I think anything less than 3 days of panic means like, I might have to care on a weekend. Which,
only when you do speed rolls of the KSK.
Yeah, Yeti intend also to test things like faster keywords, something like that. At the beginning of DNSSEC, typical validity period of signatures was several weeks. Now that we are getting better and better, I hope so, we see signatures of only a few days. Like signature validity period of only a few days. So, well. So again, if someone knows Perl and wants to add this feature, it could be useful. DNS, now that's what monitoring. Now to assess the quality of the DNS delegation, as I said, testing a root is a bit more difficult. Some programs have problems. For instance, Zone Master, which is a very good program, highly recommended. Very cool to test the zone, but it cannot test the Yeti root. The bug has been recorded. Now you just have to wait for the maintainer to find a way to solve it. I tested this morning, even the web interface does not work and the local installation does not work either. So you cannot use it for Yeti, unfortunately. But it will be solved. But it's a typical example that you cannot just take any DNS tool and use it on Yeti. It's more complicated than that. DNSMon is another example. It's supposed to be a dot here, not a slash. DNSMon is used by many TLD and of course by the official root. Can you use it to monitor Yeti? I'm not sure. I didn't ask the IPNCC people.
I think this should be straightforward to do. If we define a forward domain that has the Yeti roots as its members, then it should be able to monitor that without any problem.
Yeah, but the query has to be done with a QNAME dot, not with a QNAME of this domain. So it may work. Also, DNSMon is supposed to be there to monitor important zones. But of course, Yeti cannot say to be important. So well, I will ask the YPNCC people about that. So we'll see.
Well, right. DNSMon uses that list now, I believe. So yeah, we can define a measurement to do this, and then ask them if they're willing to present it on their webpage, basically, right?
Yeah, but it won't be exactly DNSMon.
We could potentially configure the ORC TLD mod to monitor the Yeti.
That could be cool.
Servers.
Yeah. If it doesn't use too many resources, it could be cool. On DNSViz, which is well known for the beautiful graphs that they produce, the web interface always goes through the official root, but if you have a local installation, if you install free software, you can install it on your machine. Then you can use it to analyze the Yeti root. It's not really user-friendly, but it works. The first one, gather information from the Yeti name servers. Here, it's a list of the Yeti name server, so minus x dot colon on the list of servers. You put this in a JSON file, then you can analyze it. You just have to be sure that you pass the Yeti key here, because by default, of course, DNSVs use the official key. So you read the JSON file with the Yeti key, and you can produce a text report here or a graphical report here. Here is the text report. It's okay, because otherwise, if it's not okay, instead of the dot here, you would have an exclamation point. If you have a dot, it means that everything is okay, and the key which was used is indeed the Yeti key. So it works, and don't worry about the NX domain. It's a good thing, because DNSVs test a random name and test that you get NX domain and that it is properly authenticated by DNSSEC with NSEC signature, etc. It's important because some zones work fine for no error request, but fail when there is an NX domain. For instance, many middle box, we are talking about middle box, many middle box strip NSEC, for instance, or NSEC strip. So everything works fine until you try a name which does not exist. And here is the graphical representation of the Yeti root. So here is the Yeti key. The KSK signs itself, signs the ZS key. There is an NSEC proving that this name does not exist, that this type does not exist. Dot here is the root. So there is no CNAME in the root. The goal of testing a CNAME is to be sure that in the case of no data, no error, answer 0, we get a proper NSEC. It works. And I don't know why there are two SOA, so probably spurious. But then it's here to show that you can have the beautiful Yeti graph, DNSVs graph with the Yeti root. You just have to install DNSVs locally on the, it doesn't even need to be a Yeti machine because you give it the list of Yeti name servers in the command line. If it's a Yeti machine, it's less complicated. So it works. It's boring because it works. But if, for instance, one of the name servers of Yeti had a problem at this time, we would have some red lines in it. You can have also some tools. Shane was mentioning Go to write a DNS program. I'm also a big fan of Go on the Go DNS library. So for instance, here is my own version of CheckSOA. Every programmer in the DNS world wrote his own version of CheckSOA in Perl, Ruby, Python, etc. This one is in Go, and you just ask all the name servers of a zone and display the serial number on the RTT. This was done from a machine in Tokyo, so that explains that the machine, the white machine here, has a much better RTT than all the others. But you can see that everyone is fine. Again, if there were a problem, it would be displayed here. One of the reasons why I developed my own version of CheckSOA, it was not only to learn Go, it was also because some of the existing versions have problems with IPv6. Which, of course, for Yeti would be a real problem. The white atlas probes now. So for those who don't know, the probes are small hardware probes. They are described in a lot of details in the last issue of the Internet Protocol Journal, something which I strongly recommend. Read it. So they are distributed to volunteers. They plug the probe in the network, and then the probe contacts its master, and then performs a lot of measurements and uploads the results to the master. There are something like 9,000 probes currently working, which is not even one in every AS in the planet. So we can do better. We can increase the size of the botnet.
What's the penetration of IPv6 probe? I mean,
because
not all of them are two-stack.
This is the important word. volunteers, which means that the probes are not installed in a typical network. The networks they use are more geeky networks. So 1/3 of the probes have IPv6 connectivity, which is much higher than the typical internet machine. Also, 1/3 of the probes, no, 1/2 of the probes use a DNSSEC validating resolver, which is again much than the typical machine. So because of that, be careful of the test with the Atlas probes. They are not they are not representative of the mom-and-pop user. Also, one important problem for us, because it's done by the WIPE NCC, the majority of probes is in Europe. So, but we can fix it. There are people who are called Atlas ambassadors. It's the people who go to meetings with a bag full of Atlas probes and they distribute it to the people who pledge to plug them in their network when back at home. So it's especially interesting for Asia because we miss probes in China and in other countries in Asia. So it's the meeting in Yokohama is a good opportunity to have much more probes. You have on this page, you have the list of WIPE ambassador and people who can give you Atlas probes at this meeting. So the probes can test with ICMP, DNS, which is important for us, and with a lot of options. You can change the query type, you can change the do bit, the CD bit, you can change the eDNS buff size, etc. You can also test threshold on NTP, less important for us. And the measurements done by the probes can be chosen by the users, which is, of course, very important for us because you can decide of the measurements to be done by the probes. You can do it through a web interface or through an API. Of course, the good thing about the API is that you can reproduce a test. For instance, you can have a periodic test, or you can do a measurement, change the parameters, and do the exact same measurement, which is much easier with an API than with a web interface. So I prefer the API. There is an official command line program which is currently in beta, but many people already developed libraries to use the API. And you can select the probe, which is important. You can select them by the country. So if you have a problem and you suspect that it is specific to a given country, you can test the probes in this country. You can select by region being very large, or the AS number. If you read the documentation, you will see that you can select also by the IP prefix, but it doesn't work. So here is a test which works. You test a Yeti server and from Canada. So this program here uses a WIPE Atlas library to talk to the API. You indicate here the country, the IP address of the machine. Here, 46 probes participated. It's all the probes in Canada. And you can see that majority of success, only one timeout. On 46 probes, only one timeout, which is not too bad given the state of the IPv6 internet. Yeah. So this server seems okay, at least from Canada.
I think they added a way recently to only specify good IPv6 probes.
Indeed. That's actually what I did in the real test. Because, yeah, one of the points of the probe is that it's something which is quite specific to IPv6 again. Many machines believe that they have IPv6, but they are not, but they don't have it. I mean, they receive a prefix in a router advertisement, so they configure a global IPv6 address, but actually there is no routing. Or when there is one, it's sometimes very fragile. So this is something which is quite specific to IPv6. If you don't add this option, you will get many timeouts, even to well-established servers. That's something very important to keep in mind. The IPv6 internet is at the level of quality of the IPv4 internet 20 years ago. Many often partitioned, in several parts which do not communicate, high percentage of packet loss, this sort of problems. And typically handled by people in a best effort way only. When you report to an operator that the IPv4 transit is broken, they typically don't go to lunch until it's fixed. When it's IPv6, they tell you that, oh, IPv6, oh, Jim knows about it. He's on holidays, but he will be back on Monday. That's why the current level of IPv6 quality on the internet is so low. So yes, there is this option for IPv6. Unfortunately, there is no equivalent option for DNS, which could be useful because I know a probe, always the same, which talks to a resolver that replies refused to every query. So every time you do a DNS test and you fall on this probe, you have a spurious refuse. Unfortunately, there is not yet this tag for bad DNS resolver. But there is a tag IPv6, so if the probe can ping some well-known targets, it is eligible for IPv6 tests. And yes, it's a recent change and really useful. Here is a test with the DNS. This time we don't use ICMP echo, we use the DNS, only from AS 15557, which is a big ISP in France. So we indicate the AS number, the name server that we want to test. If you don't indicate it, it will be the default resolver, the type, and the domain name. So in this AS, we have 16 Atlas probes. On all of them, the 16 of them retrieve the same SOA, which is a good thing. You can also indicate the RTT, but I didn't use the proper option. So this example is the basic of the test that I sent on the mailing list a few days ago with a script testing all the Yeti servers and to see the average RTT and the percentage of packet loss. We have two root name servers which have a big problem, a lot of packet loss. One, it's because they use a rate limiter. One of the routers in the project uses a very strong rate limiter, and another, as far as I know, has a poor IPv6 connectivity. This is the thing I was talking about. That's all. If you have questions, oh, by the way, the Atlas probes, the good thing about the probes is that they can do a test from many points of the internet. So you can use them for things like finding AS112 servers, because the probe can use its local resolver, the one indicated by DHCP or things like that. So you can have a good idea of, to test any cast servers. It's really useful. Because from just one point from your network, you have a very limited view of the internet. And if you want to test with open resolvers, there are. Keith also was mentioning the use of open resolvers. I do this through the DNS-YO program. DNS-YO is a free software program which comes with a list of pre-configured open resolvers, and you can do tests on open resolvers very easily with it. You say DNS-YO hostname.as112.net, and paf, you have the reply which is specific to every instance of the AS112, and you get a good idea on how many instances are there, and which one is the more common, etc. So basically, the point of this talk is to say that we should use these tools in Yeti to prove, to check that everything works fine and to prove it to the others. Any questions or remarks?
Well, I guess, I wonder if there's a better way to coordinate all the checks that you're doing and we're doing and things like that, so that we can be, so that other people can be aware of the work measurements that are going on, and we can, I don't know, make it a bit more open, or I don't know.
In my opinion, the good thing would be to have somewhere on yetidns.org a status page, actually two status pages. One which is a manual, where the coordinators can put recent news, operational news, and one which is automatic, using tools like this one. So even if the coordinators are busy or something else to do, everyone can check what's going on. Software like Isinga, for instance, allows this sort of thing. So together with DSC, we could use this sort of tool to monitor. And we could use also Atlas probes on things displayed from the Atlas probe also. Of course, I'm volunteer to work on this if there is sufficient interest. But because the internet is open on Yeti, it's also a good thing if many people do the measurements on the test by themselves, because it does not depend on the goodwill or honesty of the coordinators. But yes, it would be cool to have a reference status page automatic, and I volunteer to work on it.
Okay, that's quite cool. You know, we have only one page right now that we update automatically with status, which is sort of handcrafted. Although I believe we also do have a monitoring system formerly known as Nagio set up somewhere that we use internally that we report, that we don't export. So, okay, we're also about to put a new version of our web server up, which will make it easier to take contributions. We're going to use, what was it? What's it based on? It's a Git-based thing, so it might be easy for external people to publish changes and things.
The details can be sorted out after. The important point is that we are currently a bit low on monitoring and public monitoring and measurement. We can do better.
I think maybe one of the goals of the Yeti project is to make sure how many root name servers is enough. So I wonder, do you have a detailed plan to how to measure and how to get the output of the answer? Or do we have a plan to measure, to starting to research on the result?
So that is on the list of likely future experiments. We're going to need more operators before we can even consider that, and there will have to be some planning. So I don't currently know what the experiment will look like beyond trying to get us up to having 30 server operators and hopefully more than just a few dozen recursives, and get our query load up and find out what the experience of that population is. But beyond, we can't simulate it. It makes no sense to build a lab network like this. So once we have grown the network enough that this experiment makes sense, I think it'll be up to this community to decide what the experiment will be, to find out what the impact is.
I want to add some comment. I'm very interested on the measurement part, because in my slides I told their lack of experiments end to end. We need some. We now have some traffic, but we just connect them. We need more to find something from the data, from the traffic, right? And also considering as an organization how to management this project, I come up with the idea that we can propose the experiment protocol. We can come up with some procedure to involve like you, other researchers who have personal interest to work together and to set some task force or or work parties, so can periodically exchange ideas and make calls and make clear goals what subsystem, like monitoring system, what we want to build. It will helpful in the future experiment and measurement study, I think. That's my comment. So.
There is something also to keep in mind for this, and it's one of the things that interests me in Yeti, and personally, one of the reasons why I'm happy to participate is that Yeti is not only a technical experiment, it's also a social experiment, because we have to manage people from all over the world. We don't have a strong leader. For instance, there is no one who controls the money and the budget and can force people to do this or that. So we have to convince people and we have to work together. And this is something that is reminiscent of the beginning of the internet, and it's very interesting. But it's also a problem because, for instance, if we want to measure, for instance, can we have 50 root name servers. Will it work? That's a technical point. But then there is a social one. We need 50 volunteers. And today we don't have them. If we have only 14 root name servers in Yeti, it's not because there is a limit, a magical limit of 13 or 14. It's simply because we don't have more volunteers. So this is something important. And when you test quality, well, to tell the truth, there is one of the name servers of Yeti which has the problem very often, much more than the other root name servers. So we have to address this. A simple way is to fire them, but we don't have enough name servers. And the goal is not to fire people, it's to make everyone get better, participate, improve, etc. So this is also a very important part of the project. Outreach, convincing people, recruiting people, finding volunteers, and once there are volunteers, helping them. Many of the people, for instance, there are no Yeti root name servers in Africa. I tried to convince several people, and I found two different categories. People who say, oh no, I would never dare to manage a root name server. I'm just an ordinary engineer. I cannot do so. It must be very complicated. I'm not a volunteer. But there are also the opposite. People who say, yes, I want to be a root name server. I want anyone has a right to be a root name server operator when they don't even know how to use it. So we have both problems. And I think that Lars-Jan wanted to talk.
I just want to say, I also asked people in Africa, or just quickly, I'm sorry. I did ask people also from Africa, but the problem that I found was people didn't have non-tunneled IPv6 access a lot of times. But I did some checking recently, and I have a few ideas, but yeah.
I have two comments. One is that we're going to find out the sufficient number of root name servers. I believe the number is far fewer than 30. Fewer. Yeah, 2 or 3, something like that.
So similar with both.
Yeah, so that's one. The other comment is that there is already a social experiment ongoing. It's called ICANN.
Okay. That's all for your part. Okay, thank you for the postmail. It's a presentation to introduce current state of art of using different tools to measurement monitoring system. Very appreciated. Okay, our last speaker, Dimitri. Thank you. Okay, let me change to your slides. Wait for a while.
And can I change it by myself?
Okay, no problem. But how can I turn it out? Different. Okay, sorry. Close it. The last one, I think this it is. Okay.
Okay. Hello, everybody. Well, all know this cool Yeti logo. Let us see how this beast feels himself in Moscow. So I'm Dmitry Kolovenko from Moscow Internet Exchange, and I'm going to tell you about Yeti Experiment Lab in MSKX.
Okay. Oh, you turn yourself, right? You want. Okay.
So Moscow Internet Exchange do business not only as IXP, but also is a DNS service provider. We run some authoritative DNS servers for top-level domains, second-level domains, and we are running some recursive servers. As a DNS server provider, we are interested in such projects as Yeti, and our goals in this project is to get extra experience in DNS field and to test software that can be used in our production environment. So the code from Yeti site very well suits our purpose. So that's why we're here. And let's talk about what components do we have in our Yeti environment. I shall divide them into two groups. First one is DNS, where we have a physical root server and a virtual recursive, which stands only for internal tests and do not serve external queries. Another part is monitoring. We do several check number in root zone in distribution masters. Also, we represent statistics from our Yeti resolver with help of Hedgehog software. And we do some experiments with DNS queries, and we'll talk about it in details. So we did this network design to run Yeti tests. So we have DNS cache platform, and we tapped some queries that are going to this instance and mark it as original. Then we proceed these queries at Yeti resolver, and you should understand that in this case can be only UDP queries. So we do recursion in Yeti environment, then send replies which are blocked at our network equipment to avoid duplicates to users, and we represent by DSC the statistics from original instance and from Yeti resolver. So here you can see some statistics from original instance. So here are both IPv6 and IPv4 queries and error values for this replies. And another one is Yeti DNS stats for the same queries, and you see that they are quite similar until I do some reconfiguration and have broken IPv4 recursion in Yeti resolver. So when I did reconfiguration, all IPv4 recursion was blocked, and here you can see the results. The amount of no error response significantly decreased, while serve fails went up. So this is current situation for for users for this particular instance. So, and here are some results. You see that 2/3 of valid queries finish with serve fails, and the major reason was a lack of IPv6 connectivity. There were some additional things. For example, no glue records in top-level domain. I didn't find any problems with Yeti root environment. And the main idea of the experiment was to test our network design and this tool, that it can be used for some Yeti experiments analysis further, because some experiments I intend to be long-term, and as it's fine to see when something happened and to go to raw data and to analyze this data. So here is results for this experiment. And while I was setting up our lab, I saw some things that I want to mention. Some of them are outdated now because something is fixed. But we saw notified that were coming from this IPv6 list, and there was only one distribution master in this list. This problem is fixed for this distribution master, but there is a problem for white DM. Also, we saw a problem with our monitoring model that did not see this DM replies, but now it's fixed and it's all green. It's fine. And another thing, what I want to mention is when I was setting up Hedgehog software, I saw or noticed that it can produce RSAC reports, and it can be a good idea to have such tool at BI site near raw data to build RSAC reports for all Yeti project. And to recap my presentation, I want to say that we have Yeti resolver, Yeti root, and we compare DNS air codes replies for real and Yeti environment. So this brings me to the finish of my presentation, and if you have questions, you may ask.
Right now, the 3DM that worked yesterday, Power Build is up. I'm told that in your lab you mirrored some traffic and replay in the Yeti. Do you have any observation of some technical findings during your experiment, such activities?
As you saw, I ran just only one experiment with IPv6, so I tried to block something in parallel environment, in Yeti environment, and to see the results. So there may be some additional experiments that Yeti Lab will run, and we can use this tool to understand is the experiment worked for us or not for the resolver.
I have an interesting question is that if you play the traffic to the this is David. If you replay the traffic to the to the Yeti with the recursive side, I'm actually don't know how you use the recursive, use the instant to replay just as audio query or not. But my curiosity is that the distribution between all the Yeti servers. Do you have any observation on that?
So we do replaying in real time. So it's not replaying; it's just real traffic that we send to our Yeti resolver, and the distribution is that almost all queries are going to our Yeti root server that is running in Skyx lab.
Okay. Any questions?
Yeah. So you have query logs from your production service that you're mirroring as well as Yeti. Did you do? I'm sorry if I missed it. Did you do sampling between the two to see if they're giving identical answers?
No.
Can you rephrase?
Oh, sorry. Did you look to see if the answers that you're getting from the IANA route are the same as the answers that you're getting on the Yeti?
No, I did not look into IANA and the difference between these recursions. It was only client side incoming queries and outgoing responses. So that was the idea. So maybe it's a good idea to do such kind of measurement.
Yeah, it would be non-trivial to do because you'd have to match them somehow, but might be interesting.
Yeah. People may argue that the mirrored traffic replayed in the testbed is not good evidence, not approved as a real traffic. We need to compare the response, right? To say is it because now we are just connect the queries. We are not measurement the feedback from the resolver. If you replace some traffic, you can make some observational study of the response you get from the query you send. That's maybe some technical findings there.
I want to say,
Not tonight, just a visit. Okay.
so I want to say thank you for your bug reports, but you can also open tickets. We have an RT system. Anytime there's anything broken, you should open a ticket because that creates a permanent record of every mistake we make and how we solved it.
But I think it will be good to mention in your presentations that you have some tools to report, and I didn't find it.
It's not on the website. It was the RT system was sent on the mailing list, but it's not on the
How to
website.
use RT to
Shane?
public.
Is that a to-do list for you?
Okay. Okay. Yes, thank you, and okay, thank you, Dimitri, for your introduction of your work, and also considering. Well, that's all for the second part and for the home. Actually, all the speakers for the presentation. Firstly, I want to thank you all for your preparation and your participants in this workshop, and also I'm inspired by some ideas, and we build more from my side to I would like to be more open some tools now we're using to run the project, like the RT system, like some repos. Actually, we use a new model of the website to can encourage the participant to post some like blogs or some documents. I will open that afterwards. And okay, that's all to show to just show my thanks to you. And then we still have some time for some open discussion and for as a conclusion or according to the slides we have already. Yeah. Okay.
I have just one topic that wasn't on the agenda, maybe to kick off an open discussion, which is that we mentioned that there was kind of this 3-year time limit to this. And so Warren Kumari at Google was originally very hostile to the Yeti project, but then we haven't done anything evil yet, so I think he's less hostile. But he has one big concern, which is that we don't seem to have a well-defined way to turn off the project. While we may have an expiration time set and the expectation that we're going to stop after 3 years, it's not clear exactly how that's going to happen. Is it worth spending effort on that now, or is it something we should worry about when we get closer to the time? I mean, the later you wait, the harder it's going to be, but on the other hand, we may have no idea of how it's really going to work this early on. So I guess I'm just curious if anyone has any thoughts about that.
Assuming you have a success disaster, you might finish up in a situation where people configure using Yeti and then there's a personnel change and they go away. So you would kind of need some kind of smooth wind down mechanism that redirects the route to the real route or resolvers. Just a thought.
On the website for the people who configure Yeti resolver, it is set to email to the coordinators. Do the coordinators keep a list of the resolvers using Yeti so we can tell people when we stop?
It's on the website, right?
No.
The emails that we've received.
Okay, so you keep the email.
We don't get any emails.
Actually, there are only 2 registrants on the website from. I think from you. You have a 2 resolver, right? We have 1, and then I think one answer to this question is that we have
when we're approaching to people, encourage them to use, and we definitely have communication contact with these people, and we can. Well, it's easy to turn off the authority server, but it's hard to trace back, right? We firstly, like the BPT and other institutes, we keep connection, and then there are other approaches that we recall the recursive the IP address. We know where it's from. Maybe it's a way to inform the organization like Seasoning. People use this Yeti, generate a lot of traffic. We know the traffic from them, so we can send mail as a procedure to all the address that belong to. Well, currently it's just less than 100, right? Less than 15, I see. It's easy to turn off, and it's not going to a problem.
Can be clear for me one thing, because we did not post this our Yeti resolver to coordinators, because of its internal only, and the list of Yeti resolvers that you're publishing on site, are they open for everybody, or it's maybe for closed things?
You mean?
So the list on site, on Yeti site of servers that do recursion, are they public available and they are open resolvers, or they are?
From the DSC page, it's open.
I don't know if we ask people if the resolvers are open. I assume that most of them are not open, but I don't know.
For instance, the one in BII is not open. I get refused.
Good.
Okay.
Well, yeah.
Oh, you mean
Which is good
open
practice.
for queries, right?
Two more comments. One, operational contact information will go stale if you don't periodically refresh it. With a half-life of less than 2 years, I would say.
Yeah.
The other thing is that we have operated various testbed open resolvers at Borg, and I can guarantee you that people will find them and they will use them for purposes that they were not intended. You need to monitor and protect your resources and stop them being misused.
One last thing, frankly, I'm very surprised by Warren Connery remarks, because on the web page it's clearly stated that before you configure a resolver, be aware that it's for non-critical use in non-production environments. So I think that we are honest. We tell to people that it's not for don't put your ordinary unsuspecting users on Yeti just like that.
Yeah, every user should be aware. If there's some problem, he can check and return to the original.
I agree in principle. We're being as forthright, as direct as we can, as clear. But as you know, on the internet, I mean, we are 2 hops away from the users at least, and there's no contract to send a packet on port 53. So I don't know. I mean, we can look at other examples of turndown, and it's been tricky in many cases. Like ISC is still trying to turn off DLV. The 6-bone took, I forget, 2 or 3 years to turn down or something like that. Because in both those cases, no one really expected that it would go on for very long or that it would be used for other things. But I mean, the service works. I had to turn it off because of bootstrapping issues, but I was using it at home, and my vast user community of my kids and my wife never reported any problems. So it works in production. You can just accidentally install it as a test and then let it run for years, right? So.
If we change another view, what's the problem if there is no specific wear plans measure to turn off the Tesla? I don't know.
We just want to. Well, we won't get sued, so from that point of view, there's no problem. We probably won't get arrested, although laws can change. I don't know. But just we want to minimize human suffering, I think, is the main thing. And what we really don't want is at the successful end of the project, we delivered our final report to ICANN with our full set of recommendations for how to tweak the root servers. Then all of a sudden we get a bunch of bad press on the register or something.
Yeah, the examples you mentioned were big success, like the six board, which were not planned to be such a success. I think you have also to consider the vast majority of experiments who never had this problem because they never used.
Right.
Today, the biggest problem of Yeti is to get more users. If I would love that if our biggest problem would be to tell how to reach all our users who rely on us. But today we are very far from it.
Yes, very far.
Maybe it will never be a problem. Yeah. Okay, so it doesn't sound like there's any strong appetite for spending a lot of time worrying about this. I guess if we meet together in a similar workshop in a year and we have 10 times as much traffic and so on, then maybe we can consider it.
We can add some practical advice on the website because I've seen it quite often in experiments. There was something like, this is an experiment. If you use it, be sure that you are on the mailing list so you are informed.
We say that, yeah.
No, I don't think, it doesn't seem so. It's join us as a resolver. Inform users in non-critical environments, but it's not written explicitly that you must join the mailing list. For instance, when you if you use Debian, if you use the unstable branch, the brand new one, there is something like you should really be on Debian level because otherwise you will get a surprise, this sort of thing.
We may take it for granted that who use services will be interested and joining the main list already.
Yeah. Okay. That's good to update you, right? Okay.
Dimitri?
Another question, do you have any scheduled plan for further workshops, just to plan activity?
Right now, we don't have any other plans for future workshops or meetings. We haven't discussed it. Do you have recommendations?
This is first open and public workshop, right? Because we have a bunch of things we want to share, and we have the need to request for some comment and plan for the experiment. So that's
And about further experiments, do you have any ideas that you run this year, next year, just to
I know your question is experiment agenda, right?
I think, yeah, it's kind of the experiment agenda. We don't have that published right now. As I said, we want to do this multi-ZSK as the first experiment. I would like for that to be finished this year. I don't know if that's feasible. It should only take a few weeks to run the experiment once it's defined and accepted. So, and we should be able to finish it and then move on to the next one. But we don't have a full.
But surely, I think our project. I just on my individual behalf myself. We have some research goal, right? We definitely want to let people know what we have done, and there's a technical merit advantage to deliver some well done document to influence this community and to persuade more people to agree on us on some issues. Some are technical ones, some are social, political ones. Yes, I think as Paul said, and I also agree that this project is driven by community. I think we can discuss any questions in the main list. We have discussed main list, operating main list, right? I think just after this meeting, I also suggest that the participant of Yeti we can set up and have some summary and for some plan. Or later on the main list, it's okay. It depends on your time scheduling out workshop. Yeah. Okay. Actually, I have to admit that it's maybe my problem or maybe the coordinators are very busy, and we are not a central organization, a central company can decide everything and schedule every month's plan and the goal. We try our best, and I think Postman also mentioned that they like its way just as the internet began. And I think if we have any suggestion or experiment plan, you can follow the our experiment protocol, even though it's not very formal and official, but it's what we got here. And I think more participation and contribution to the project is welcome. And I also want to mention that become one of the Yeti participants as a root server or DM. Not there is not anything to show up or to as a owner. It's a kind of you are part of us. You have the platform. You are on board to do some experiment, right? To do some interesting topics. Some of our operators now just silently volunteer and contribute to our server. It's okay. And we have some rules about it needs several days feedback. If the server is cannot provide enough to say the performance, maybe some server will get rid of the group of people. So yeah, we are increasingly, gradually, will make the rule and make the process more clear. That's what we are, where we are now. Paul, do you want to add something as a conclusion or summary, or some suggestion?
I think so.
So I hate to ask people to do stuff that I haven't done. So while you were saying that, I switched my house over to Yeti. I changed one managed key in nameb.conf, and I did a dig command to create a new cache file. It's that easy. So I hope everybody will do at least that, because even though it's not really meant for production, you guys are not production. You can cope with a little bit of slowness, and it's not going to be completely out. So yeah, I really want to amplify what Davey was saying. This is supposed to be a community effort, and you know, we made sure from the earliest moment that there was no king, no possibility of a king. We don't have rough consensus and running code. We just have doing the obvious right thing, and if it isn't obvious, we don't do it. I want to make a special thank you to Stefan, who has been our biggest pusher.
Actually, yes.
So this is wonderful. Thank you all for coming, and we'll be around for the rest of the night, so we don't have to leave. We got the room, but I think this is time to turn off the projector and mill about in the hall.